vulnerability indices. We'll talk a bit about how we go about constructing indices in this vulnerability domain. And then what I'll do is we have a little exercise. So we're not going to call it a tutorial because I can't do that apparently, but it will be a lab exercise that you all can just do at the end of this particular lecture. And then what I want to do, and this is all providing I'm able to pull together all the data, is tomorrow I'd like to actually have data available for each of the states of India for us to just practice constructing an index together. So it would be a little bit of a tutorial. Now, for those of you who came and said, I really want to learn about climate mobility and we're gonna miss out, you're not missing out on anything. There was one lecture tomorrow on urbanization, vulnerability in urbanization, which frankly, I had not yet prepared, and I didn't have a lot more to say about the topic than what I said on Tuesday. I think this will be a more fruitful use of our time. So what we're going to do is we're going to move the theory, migration theory, and climate mobility lecture to right after this one. Tomorrow, you'll have 2 lectures on climate mobility first thing in the morning. Okay, one is going to. I don't know what's going on. Maybe it's battery or. Perfect. So to continue that, tomorrow 2 lectures, one on literature review around climate mobility and migration, a second one on quantitative modeling approaches. So you're not going to miss out on anything. I'm just adding some content that I think will be valuable for you. The tools that we'll be using for index construction is nothing more than Excel or Google Sheets. So we're not doing anything fancy. If you prefer to use something like R or Python or Stata or SPSS, you're welcome to do that. Does this make sense? Everybody on board? Okay. So let's go ahead and get started on this topic. One thing I wanted to do is go back to yesterday's lecture about vulnerability mapping. So I went through very rapid fire the approach that we took for Mali, the country in West Africa. And at the end, someone came up to me and said, well, could you clarify this one point about the steps that you took? And so I felt it would be better if I just laid out the diagram that we use for the vulnerability mapping. All of this is available in the step-by-step guide, which is also in the list of reading materials that you have. So you can, look on that list of reading materials, the content guide. It may even be, I'm not sure if it was downloaded or not, but it may even be on the drive right now. And so we laid out everything in there in much more detail. But, I mentioned some of the yesterday about identifying the framework, identifying, what you're going to include, what you're not going to include, the resolution of the data, the audience, et cetera. And then we had to choose the data layers. And we're going to talk more about choosing data in this lecture today. So you'll hear more about that. Then we process the data layers. So I mentioned, that some of the data came in the form of points, some came in polygons, some came in raster grids. So if the raster grids were too coarse, we had to resample and go down, the native resolution remained the same, but we had to resample so that everything was basically in a consistent 30 arc second or 1 kilometer grid resolution in raster format. So this was a conversion process here. We got everything in the grid format and identified the statistical, I'm skipping because the arrows point here. So what we did is we created a fishnet. This is a standard GIS technique where you essentially get for that raster, you get the centroids for every grid cell. So you can convert in GIS, it's very easy to convert from raster to points, okay? So you get a fishnet of points, each with a unique ID. The reason you want to do that, and I'll show you later, is basically you want to do some of the processing in statistical software, not in ArcGIS. It's just a lot easier to do a lot of these steps in another tool. So then, each with a unique ID coincident with the centroid of each raster. Use extract values to points tool to transfer raster values to the point attribute table. Okay, so you have points. To get the values for each point, you need to transfer from the raster layer, which has precipitation levels, or it might have education levels, or it might have some other value. Mother's maternal education was one of the values I mentioned. Household wealth was another indicator that I mentioned. So you transfer from the raster to the points. Once you have everything in a points, you can basically convert it into a CSV, a comma-separated value file. It's essentially an Excel sheet, a tabular sheet, which you can then process in any tool. We list R here, but you could use it in Python. You could use it in Stata, SPSS, etc. Each one may have different limits, though, in terms of the number of values. So if you have a really large, like global raster data set at 1 kilometer resolution, there may be limits in even Excel to the number of rows and columns that you can have. They've changed a lot of those limits over recently, but in the past, limits. Step 9. Am I doing something wrong? You changed the batteries. Okay, changing it again. Perfect. All right. That also gave me time to get my timer going. So step 9, we do the transformations to the data, basically trimming the tails, logging values where there may be skewness in the values, things of that sort. And then we calculate all the indicators on a 0 to 100 scale. So that's a transformation step where all the indicators are done, calculated on a min-max transformation, which I'll talk about in a moment. Then in R, we calculate the sub-indices for exposure, sensitivity, and adaptive capacity. So each of these, once you've transformed the data to a 0-100 scale, which is a unitless scale, you can then basically aggregate them into sub-indices within the overall index. Then in R, we calculate the overall vulnerability index using the components. We also ran the principal components analysis. Finally, you want to see what all this looks like at the end of the day, right? So you need to join the tabular outputs to the centroid layer and then use the point to raster tool. So that's going back from, instead of going from rasters to points, you're going from points to rasters. And once you've done that, you can basically use the grids in ArcGIS or any other QGIS or any other tool to basically map out the results. Hopefully that's clear. What did I do with the clicker? And then at the same time, importantly, you want to make sure that you document all the steps you took. So what's easy to do is start playing around with the data and doing this and doing that. And then you move on to the next indicator and the next indicator. And before you know it, you forgot what you did to the first indicator. Now, if it's all scripted in R or something like that, you can go back to your scripts and see what you did. But in some tools like SPSS, you may not have a breadcrumb to show you exactly what processing steps you took. So these are some things that are important to remember. Okay, so today we're going to talk about developing a composite indicator or index. And this is the reference tool book that I use, and I think a lot of others use when they teach about the topic of composite indicators. So I just commend it to you. If you don't have it, you can download it. I'm going to be using elements of this today in this step-by-step processing that I'm going to discuss. So we'll jump right in. The outline today is step-by-step instructions, and then we're going to do a little exercise with Human Development Index data to see how two different types of aggregation methods change results. So here are the step-by-step instructions. We've already talked a bit about theoretical framing. So in the vulnerability space, we've already seen two different framings. One is the original IPCC AR4 framing, and the second is the IPCC AR5 framing of risk. And so this would be largely, for the most part, what we would use in this context for vulnerability mapping, but you could choose another framework if you wanted to, and I'll show you what I mean by frameworks. Why is it needed? Okay, for part of the reason it's needed is, I was talking about causal diagramming. So you want to know how the variables are related to one another in a kind of more systemic approach. And so the theoretical framework should enable you to be able to describe that. These are very common early frameworks that were used in the sustainability space, in the space of developing composite indicators of sustainability, which was basically state pressure state response, PSR. Pressure meaning emissions per capita, state meaning the level of CO2 in the atmosphere, response meaning government makes some policy decision and they decide to limit emissions. Then people, started talking about, well, instead of pressure, maybe we should talk about driving force. Driving force would be population numbers or total GDP per capita or some other number that basically reflects the driver behind those emissions. Does that make sense? So these are some framings. And then ultimately, they started getting a little bit more complicated yet again and started saying, well, driving force, the population and the GDP drives emissions, and emissions then derive the state of CO2 in the atmosphere, and then impact is the impact on the environment, and then response both affects driving forces. So you could have a population policy, you could have policy related to emissions that says you simply can't emit as much, or you have to adopt, like if it were air pollution and not carbon dioxide, you could have smokestack scrubbers or something like that that would remove SO2 or sulfur dioxide from the emissions. So these would be policies that would affect overall the state of the system. So that's what I mean by having a framework is basically the same thing as I was talking about earlier. You want to know how these things are more or less related to one another. I'll skip the language up here. It's all there for you to read. But so this, again, the theoretical framework, it's a theoretical framing of how things fit together. Individual indicators should be closely aligned with the main areas. So if you have components like exposure, vulnerability, adaptive capacity, you should try to fit the variables into the proper bins. They should be theoretically related to that topic. The framework should also say something about how the aggregation occurs. For example, nesting of the index, components and indicators, and possibly something about the weighting. So, you could just take all those individual indicators and aggregate them right up into an overall index without binning them into separate components. But you'd need to have a good justification for doing that and some rationale. So let's take a look a little bit further. This is, from another reading, which is really helpful, by Niemeyer and Groot. And basically, it says, in a causal chain, social and economic developments are considered driving forces that exert pressure on the environment, leading to changes in the state of the environment. In turn, these changes lead to impacts on human health, ecological systems, and materials that may elicit a societal response. And so that feeds back. And so this is an example of a driving force, mineral fertilizer prices, market demand for fertilizer, et cetera. Then you have the pressure, which is the use of mineral fertilizers, meaning nitrogen, phosphorus, potassium, which then can have an impact on the water and soil quality. And so you could have eutrophication of water bodies, which then might lead to algae and other problems in water bodies, lower dissolved oxygen, et cetera, lower transparency. And so the response might then be to say, well, we're not going to allow chemical fertilizer application at that level. That could be the policy response. That's just another concrete example of that, what we would call DPSIR framework. But other frameworks that we see are, examples here. One is, I would, say, might be a loosely coupled system in the sense that we expect these things to go hand in hand with one another to some degree, right? There's some systemic elements here, but it's not really a true system in the way we described systems the other day. This, I would say, is much more the toolbox approach, right? It's still, there are relations among these indicators, right? But the SDGs kind of explicitly just developed a large number of independent. And if you've looked at the indicators, there's, I think, 150 or 200 or more, maybe it's 200 plus. So it's really a long list of SDG indicators. And yeah, they're related to one another in one way or another, but there's not really a theoretical framing behind this. It was more that every UN agency in every country had certain agendas, and they wanted to be sure that their agenda was represented somewhere here in the SDG framing. Is everyone familiar with the SDGs? I see nods. In the US, people are largely ignorant of the SDGs. It's pretty sad. It's true. They just don't really pay attention to it, but they're really incredibly important. So here's an example of a framing in the vulnerability mapping or vulnerability index construction realm. And this is a framing which basically says you have sensitivity and exposure that leads to impact across 4 different dimensions: physical dimensions, social dimensions, environmental dimensions, and economic dimensions. I believe this was, particular example comes from a flood vulnerability mapping exercise in Germany, in a part of Germany. So they then summarized all of the total impacts across these 4 dimensions. And then they had a generic sort of adaptive capacity measure for each unit of analysis. And that led to an overall vulnerability metric. But they took here the geometric mean of these 2 variables. And we're going to talk more about what a geometric mean does and why it's useful in some cases to use a geometric rather than an arithmetic mean. I think everybody here knows what an arithmetic mean is. You add up all the values and you divide by the number of units and you basically get a mean, right? And then you can calculate things like standard deviation and stuff like that from there. So what we have here is basically, these diagrams are maybe not all that terribly helpful, but essentially, you can measure on 3 axes what's going on. You have the total impact, which is high, bad, or low, good. You have low to high sensitivity, and you have low to high exposure. And so, your ideal state would be to be somewhere down here in this corner. But if you use a geometric mean, it actually stretches the values in a different way, and you'll see that you get fewer low impact values. Okay, the lowest impact value here is something like negative 0.5. Here it's like maybe negative 0.25 or something like that, or maybe even 0. So we'll explain in a bit why you get a lower impact value, or that the lower threshold for impact values is higher in a geometric mean. One thing I liked about the way this group did their vulnerability mapping was instead of the adaptive capacity element was not incorporated explicitly in the index. Remember I talked about how adaptive capacity could be used as a divisor, or you might subtract adaptive capacity from your overall vulnerability in one of the slides the other day. So what that meant essentially, adaptive capacity sort of subtracts from vulnerability at some level. And so these adaptive capacities, in this case, the way they did it was they increased opacity. So you have total impacts from floods in this particular area of Germany, in red being the highest. But if there was high adaptive capacity, the opacity level increases, meaning that they kind of white out the area. Meaning you shouldn't be as concerned about the vulnerability in those areas because they have very high adaptive capacity. So it's sort of like subtracting out the vulnerability. All right. Have I got everyone following so far? We'll see. Hopefully it will make sense to you. So this is a really critical stage where you're making decisions about what is in and what is out of your index. And of course, some of it's going to be just constrained by whether you have access to the data or not, whether they're available data. The OECD handbook says it should be based on analytical soundness, measurability, country coverage, and relevance of the indicators to the phenomenon being measured and the relationship to one another. The use of proxy variables should be considered when data are scarce. So proxy variables are variables that basically are, might be, what would be so a proxy for whether you live in a really rainy country or not might be a number of umbrellas per household. Or something like that. It's a silly indicator in a way, but if you obviously if you live in a really wet climate, you're going to have more umbrellas, and so that would be a proxy. So you want to check the quality of the data, discuss the strengths and weaknesses of each data set. Individual indicators should be closely aligned with the main areas of the components of the index. I already kind of mentioned this. And yesterday I talked about how for the vulnerability mapping we did in Mali, we provided justification for every single indicator saying this is how it's related to the concept that we're trying to measure. Where data are scarce, be clear about the trade-offs of using proxies, and a good practice is to list ideal indicators that would be used, thereby suggesting. So one thing we've done I mentioned earlier that I've been involved since the very start with Yale University. We've been working together since basically 1999, 2000, in releasing a series of indices called the ESI and the EPI. And one of the things that, because they're global indices and because they were, at first they were released at the World Economic Forum in Davos, so it got a lot of policy attention, and you'd have ministers of environment, and you'd have prime ministers there. And they didn't like it sometimes when their country was listed low or high. So we can talk a little bit about policy, capturing policy attention as well, and that's a few steps down the road. But one of the things that I would say is that we always tried to list those data, areas of environmental data globally that really are lagging behind. And in some cases, we've had some success in improving data. And examples that I would say is that in the early days, in the Environmental Sustainability Index, which we published up until 2005, it was kind of a giant big basket of a lot of indicators, and it was a really interesting exercise. But frankly, it was not always tied to what countries are doing and their performance on the ground. What are the policies and whether they're actually implementing those policies and making things better. So we changed to this new framework called the Environmental Performance Index, which was much more geared towards what we perceived to be the need of policymakers, which is to know how are you doing on these critical things like biodiversity protection, climate mitigation, human health related to the environment, natural resource management. And so we did that shift. And when we moved to the EPI, instead of being takers and not makers, meaning we basically could only compile for the ESI those data that were already publicly available globally. And we would pull from the World Bank, we'd pull from the World Resources Institute, we pulled from other sources. And starting in the EPI, we started regularly holding expert group meetings to try to find out where the science was moving in different areas. We commissioned papers by experts. We then held workshops on air quality in Seoul, South Korea, another one on water indicators related to in Stockholm. Actually, it was at the Stockholm Royal Society for whatever they call it, the equivalent of the National Academy of Sciences there. And so we had this, so for example, out of this meeting, we developed an indicator on wastewater treatment that then became sort of the template for the SDG indicator that was later adopted. So we began to move the space a bit in terms of data production. This is an example. It's very messy, but you can see sort of behind the scenes the sausage making process when we were developing the Environmental Performance Index. And what it shows is basically where we were looking for data on different topics and whether or not we, decided to move forward or not, and the date by which we expected to be able to get all the data together. So for every year that we produce the EPI, there's some kind of sheet like this where we basically track whether or not we feel that we can move forward with a particular indicator or not. One of the notes here is that the data on nitrogen balance and the nitrogen use efficiency, which relates to agricultural chemical use, we found them to be too noisy. We analyzed the data, we looked at their distribution, and we were worried about it being too noisy. Other ones like species ranges, globally and nationally, they need to be refined. They weren't ready for prime time. So anyway, you get an idea of the kind of way that we went about as a team, looking at individual data sets and evaluating their fitness for the EPI. This is an example of a finished product, the EPI in 2016, where we had basically descriptors for every single data set and a justification for why they were included. All right, step 3, imputation of the data. This is something I'm not going to go into here, but what you find is when you have a matrix of countries and values for something. Now, I'm going to just take the example of freshwater quality. In the early days of the Environmental Sustainability Index, we actually made a really heroic effort to develop something called the Water Quality Index, which was a subcomponent of our overall ESI. And what we did is we basically took the best available data from UNEP GEMS, which is the Global Environmental Monitoring System, and then European Environment Agency and a few other country sources that measured like 5 or 6 different metrics: electrical conductivity, dissolved oxygen, I think, what's the other terms that they had? Turbidity or levels of gunk in the water, things like this. And what we found was there were just huge gaps in a certain country, and some countries didn't have values at all. So we needed to basically, in some cases, fill in individual gaps for the subcomponents of the Water Quality Index. And then for some countries, we simply didn't have data. So we used something called Monte Carlo multiple imputation method, which basically identified a number of correlates for water quality, and we're using national level indicators, and then imputed the values for those countries for which we didn't have values. So it's kind of a risky business, let me just tell you. But in some cases, you have to impute the data because there's these data gaps in the matrix. And there's whole methods for doing that. So we found that a lot of countries, like Taiwan, is not part of the UN. So we wanted to include Taiwan because it's a major economy, but it's not a UN member, so it doesn't report through the UN system. North Korea has very spotty data. So in some cases we had to impute. In some cases we decided to leave the country out because there's so many missing data. Another way, in some particular cases, if you had about 5 indicators in a particular subcomponent, what you could do is simply average around if you're missing one of those. So you simply delete that one value and average around it. I mentioned the MCMC, Markov chain Monte Carlo multiple imputation method was one of the approaches that we took for the water quality work. All right, let's look at multivariate analysis. This is where you've got all your raw data, and you have the raw variables like dissolved oxygen or particulate matter pollution levels, and you start analyzing the distribution. You check the underlying structure of the data along with two main dimensions, namely individual indicators and countries. You identify groups of indicators or groups of countries that are statistically similar and provide an interpretation of the results. And so you're starting to get into the data and explore them. Basic descriptive statistics are usually the starting point. You have, your min and max values, your means, your medians, your standard deviations. That's just the starting point. Then you want to look at the underlying relationships between the indicators. Then you want to see that the components are closely tied to levels of economic development in the case of EPI, or for our purposes, it would be closely tied to the concept of vulnerability. So one of the things that we found a lot is that we have in the environmental health sphere of our environmental performance. I'll have in a moment. I'm going to show you the structure of the environmental performance index, but the environmental health sphere, that particular portion, that component of the EPI. A lot of the indicators are very coherent because they tend to have to do with levels of development. So things like air pollution levels, access to water and sanitation, lead exposure, all of those things tend to be pretty consistent with GDP. But in the environmental domain, you might have high deforestation rates but low carbon dioxide emissions. You might have high offshore fishing rates of trawling levels, but you might be cutting all your forests down. So there's these elements in which, yes, they're all part of environmental, what we call ecosystem vitality, but they tend to be orthogonal to one another in certain countries. You're not always seeing the same patterns. Does that make sense? So these are some key points from the OECD handbook. Individual indicators are sometimes selected for substantive or theoretical reasons. It's because they're so closely tied to the issue. And they provide important information about vulnerability or sustainability, but what people tend to ignore when they develop indices is the statistical properties of each variable and how they relate to one another. So that's an important element, is making sure you understand how, because essentially, we'll see in a moment, but if one indicator is high in a component and the other, and they run in opposite directions from one another, what's going to happen? If deforestation is orthogonal to trawling, it neutralizes it. It becomes you go towards the mean of both variables. So that really doesn't help. That's what we call compensability. So you want to know what those relationships are. You're going to be assessing the suitability of the data, and this will inform later normalization, weighting, and aggregation. Let me see how we're doing on. Finally, one very useful approach that we talked a little bit about yesterday is principal components analysis. And here we want to reveal how the different variables change in relation to one another. Are they correlated highly? And if so, one valuable thing about PCs is that you can transform the set of variables that you have, the large set of variables, into a limited set, a smaller, reduced set of principal components, where the first principal component finds the greatest variance in your entire cloud of data, and it runs a line through that. And then the second one finds the next axis, which is orthogonal to the first one. And so that's a way of doing data reduction when you have a large pool of data. Okay, this is an example of just looking. Scatter plots are a very useful tool for just, most of this, you're probably familiar with from your statistics courses, but just looking at how these things are related. I mentioned earlier that environmental health is generally, countries tend to be pretty environmental health against the overall EPI score. The countries tend to be fairly, that tends to be highly correlated with GDP. but you see a lot more scatter in ecosystem vitality, meaning that the coherence of that particular component of the EPI is a lot less. There's a lot less coherence there. All right, normalization. This is an important step. What that means is that we can't just measure total deforestation in a country and then compare it to total deforestation. Total deforestation in Brazil is going to look a lot different than total deforestation in Tonga in the South Pacific, right? Brazil is a vast country. Now, one important step is standardizing. So you could begin by just standardizing the values. And so some ways this is a two-step process. First, you want to figure out what the proper denominator is. So deforestation per unit area of the country or per unit area of forest cover, starting at some baseline, is one way of doing the normalization, or looking at total CO2 emissions divided either per capita or per GDP. One approach will look more at what's just in terms of equitable distribution of CO2 globally. The other one would look much more at whether countries have large or small economies and whether your emissions are relatively efficient related to the economy or not. So that's a sort of first step, is just standardizing. But then there's an additional issue in that each of these units is very different. So units of PM 2.5 are different from rates of deforestation, are different from CO2 efforts to measure or CO2 per capita. So you want to have everything on a common scale. A 0 to 1 or 0 to 100 scale is one of the common ways of doing that. You can also do something called a z-score, which is, if I remember, it's the mean minus a standard deviation divided by the mean. And basically that gives you a metric that shows how high or low you are relative to the mean in the distribution. So let's talk about standardization first. Here are some different ways that we've standardized in the EPI. Wastewater treatment, we look at the percent of wastewater treated weighted by the connection rate of the population to the wastewater treatment system. So it's great if 50% of your wastewater is treated, but if only 2% of your households are actually connected to any kind of sewage system, that would reduce that overall wastewater treatment metric quite substantially. Nitrogen, each of these has a different kind of denominator or normalization, standardization metric that allows them to be compared to one another, countries to be compared across one another. All right, normalization methods are varied. The simplest method is basically ranking. So that if you have extreme outliers and you just rank your values from 1 to, let's say there's 200 countries in the world, I'll just say for example, then every country gets a rank value, and then you can rank every single indicator and basically use the average ranking as a way of constructing an index. It's not a very elegant way, but it does eliminate the problem of outliers. Standardization or z-scores is what I mentioned before, and basically one of the ways this can be useful, but one of the issues is that if you have really extreme values for some of your indicators, then those will disproportionately influence. So if you're averaging z-scores across multiple variables in an indicator or a subcomponent of your index, the one that has the greatest distribution, the widest spread, is going to have the greatest impact on your overall score. It's just a statistical property of the data. But it doesn't necessarily mean, just because that one indicator has a wider spread, that that's the most theoretically important indicator. So it's essentially if you just threw them all together and use them without questioning, you would essentially be biasing your index in some way by including these variables that have very different statistical properties. in a common component. Min-max is the one that we're probably going to focus on the most for this particular portion, and that's basically looking at transformation on a 0 to 1 or 0 to 100 score. And so one of the things that's often important in min-max transformation is to do a logarithmic transformation first. And that means that extreme values are less likely to kind of affect your overall component index scores. It rewards. So one of the other properties of logarithmic transformation is for some areas it may be easier to incrementally make an improvement when you're at a very low level of performance. Let's say for waste, let's just talk about water and sanitation. So percentage of households with sanitation, it may be easier to get from, say, 10 to 20% of your population that has adequate sanitation than it is to get from 90 to 100%. Because those early gains may be a lot easier to achieve. So one of the things that logarithmic transformation allows you to do is kind of take into account the fact that early gains at a low level of performance are easier than when you start getting to a much, it's a lot easier to reduce mortality by 1% at a low level of performance than it is when you get up to the point where your mortality is very, very low. I don't know if I've made that clear or not, but that's one reason from a substantive perspective and not just a purely statistical perspective that you would want to do a logarithmic transformation. Yesterday, I also spoke about trimming the tails. So when you have extreme values, the first thing you want to do is basically trim the tails. Then you want to do the logarithmic transformation. You can also just do a basic distance to reference, and this is calculated as the ratio of the country value to the target. So that could be one way that you might choose to do it. And the other is to create categorical variables. So basically, if you're between this value and this value, you get a 1. If you are between this value and this value, you get a 2, and then you go up to 5, and you have 5 categories, and 5 being the best. So that's one way, that you can look at these variables and these numbers, is basically giving things like you fully achieved, partially achieved, etc. The goal. Step 6 is weighting and aggregation. This is where this is a subjective element as well. Each step involves some subjective decisions, but I think this is the one that tends to come in for the greatest criticism when you're creating composite indices, because you're basically making a lot of judgment calls about the relative value or importance of each indicator in your framework. Let's take a look here. There are different rationales for different weights among indicators. You could have theoretical reasons. So some of those indicators that are in a particular subcomponent might be more closely related to the topic that you're really interested in. Theoretically, you could have, in a deforestation indicator, you could have one indicator which is essentially the actual rate of deforestation, and another which is the possession of chainsaws per capita or something like that. Well, obviously you'd want to measure and weight the variable that has to do with deforestation more than you use. This is an absurd example, but chainsaws per capita, would be a much poorer proxy for that measurement. Expert opinion, that's why we convene those expert groups. You would have a group get together and say, some things are more important than others, and you basically rely on that expert opinion. Salience in policy circles. I mentioned yesterday how some things are on the political agenda much more than others, so you might want to weight those more importantly. For many years, we did not break out climate change as a separate component of the EPI. Back in the late 2000s, climate was important, but it wasn't necessarily as important as it was in the last decade. And so when we started developing the EPI, the climate element was part of the overall ecosystem vitality portion. And we broke that out and made it a separate component when it became more and more salient. Data quality, you might want to weight some indicators more than others because the data are just of higher quality. The credibility of the source, I talked a bit about that yesterday, and then statistical reasons. One indicator could simply offset another, as I mentioned, the compensability factor. So if you downweight one of those indicators, it's less likely to compensate for, a low score in that indicator is less likely to compensate for a high score in the other indicator. And then there are different approaches to aggregation, which have different properties in terms of the way they affect. So the linear arithmetic mean of indicators assumes a linear relationship among the indicators. So what we kind of assume, it's implicit, we don't go spelling it out in a lot of detail, but we basically assume that if you go from with 100 being the high score on the EPI, if you go from 50 to 60 on the forest indicator, it's roughly the same as going from 50 to 60 on the carbon intensity indicator, the carbon CO2 per GDP measure. And so we're assuming some kind of linear relationship. Geometric multiply scores of n indicators and take the nth root of the product. The indicator with the lowest score has a disproportionate impact on the aggregate score. So this is one way of basically saying if you consider all of your components to be really important, and you want to address the issue of compensability, then you shouldn't allow high education to sort of offset something like infant mortality rates, where infant mortality rates are really bad. So if you want to do that, one way of doing it is to take a geometric mean, and that basically means that if you score poorly on infant mortality, it's going to have a greater impact it's going to bring your score down, your overall index score down a lot more. I think that's spelled out pretty clearly. And then in a multi-criteria method, there's no solution optimizing all the criteria at the same time, and therefore compromise solutions have to be found. Information contained in the impact index, which is useful for solving the so-called multi-criterion problem, is intensity of preference, number of criteria, weight, etc. I've seen multi-criteria indices developed. What I will say is they're often harder to communicate to policy audiences, so there's some issues with that in terms of being able to communicate the results. So as I mentioned earlier, the arithmetic mean linear aggregation, which is very commonly used, assumes that there's a linear form that basically increases of the same unit increase across a variable basically results in improvements in either sustainability or reductions in vulnerability that are kind of linear in nature. So it doesn't really address the fact that there might be threshold effects, that beyond a certain point of CO2 emissions, you might start getting catastrophic impacts, or if your SO2 emissions are a certain level, you might, or carbon monoxide emissions, you might, beyond a certain threshold, irreversibly impact people's health. So you need to think about that there may be, in some cases, in some indicators, thresholds beyond which the harm is a lot greater than if just incremental linear increase would suggest. So this one does not allow for absolute unsustainability. So, basically another element of the problem with linear aggregation is that if there is like one variable that really is the most important variable, it might not really come out in a kind of linear aggregation approach. I talked about compensability. And then double counting is another issue, that if several indicators are highly correlated, then that could create certain issues. For the EPI, we try to be very transparent about the weighting that we use. So this is one formulation that we use for weighting. Note that back in 2018, we were still including climate and energy as a part of this overall ecosystem vitality. And each of these shadings shows what kind of fraction of the overall subcomponent was went into that component. So, the ecosystem vitality is made up of 0.05 agriculture, one unit of sustainable nitrogen management, et cetera. Here you see, I think, a slightly more intuitive approach to showing the weighting scheme. This is the 2022 EPI. You can see now climate change is separated out as its own indicator with largely related to CO2 emissions, but including some land cover change metrics. Then we have all the ecosystem vitality, environmental health. And each one of these then has a wedge that shows the percentage contribution to the overall EPI. Uncertainty and sensitivity analysis is an important later step. I mentioned in the Mali case that we did some sensitivity analysis where we moved from a weighting scheme that we had proposed based on the importance of certain indicators to an equal weighting scheme. And so this is just an example of doing the same thing for tabular data using country level scores. And they basically looked at the change in ranks of the ESI in 2005 according to different weighting schemes and different aggregation schemes. And one of the things that I'll just point out is that for high-performing countries, Finland, Norway, et cetera, they're very high-ranked, so in the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Depending on the different aggregation schemes and the different weightings, you didn't see a lot of variation in ranks. Guyana is the first country on the list to have a fairly high variation. And also at the low end, North Korea, Taiwan, et cetera, you don't see a lot of variation in the ranks. Where the variation comes in, it tends to be much more in the middle ranking countries where these assumptions can have the assumptions on how you're constructing your index can have a lot of influence on the overall index score. Finally, you want to do data analysis, double check, the different components, the relationship among the components. This is where we often say to users of the EPI, don't just look at the overall EPI score or the rank of the country as your metric, but you really should drill down underneath and understand, like for the United States, how these different components interrelate with one another. And how, U.S., for instance, is doing very poorly on forests. It's ranked 115th in that case, but we are doing generally pretty well on air quality and water resource and management. So these are things that we encourage people to do. And then finally, you might want to look at the links to other indicators such as GDP. So this is a correlation of the ESI, the earlier Environmental Sustainability Index related to GDP. And again, you can see some countries are doing better than what might be expected based on their GDP levels, and some are doing worse, like Taiwan, Turkmenistan, I guess that's Belarus. Even the US is doing more poorly than its GDP would suggest. This is an example of the ecological footprint I mentioned the other day, which is hectares of biologically productive land per capita. One thing I'll just point out is that the the ESI sort of is an inverse of the ecological footprint. So a lot of countries that do high on the ESI scores also have really bad ecological footprints, with this being a bad area over on this side. Finally, you might want to do different types of data visualization. So this is the SDG index kind of dashboard. They also have whether you're improving or declining in terms of time series data. So it gives you an idea whether countries are doing better or worse. One thing I always find interesting is that, we're doing pretty well on poverty with a lot more green and yellow over here. But for for things like responsible consumption and production, climate action, and I don't know, partnerships for the goals, it's not as good. A lot of red. And then this is an example of a kind of complicated visualization, which I don't actually find all that terribly useful, but because I don't know why you want to bend your bars in that way. But it doesn't give additional information. But it's an example that someone thought, well, we should do this as a circle rather than a straight up bars. But it shows that certain countries are doing better on gender inequality than others, with Europe and Central Asia doing really well, and South Asia doing kind of not so well, and Sub-Saharan Africa doing much worse. These are some other ways of visualizing using, these kind of not quite spider charts, but using equivalent to spider charts. There's another, example of data viz from the Global Risk Report with a lot of these in the climate area, and then we have other ways of visualizing. This is how we did things with the EPI, so you could look at each country and analyze its results. So there's a lot more to say about this than I can convey in one lecture, but this gives you an overview of some of the steps for constructing metrics. It's not a linear process necessarily, so you find yourself going back to the drawing board, I should say, not the dashboard, the drawing board at certain points to do this. And some steps are more critical than others in terms of the overall influence on the overall vulnerability index or the. So what I wanted to do is take a few minutes. Let's see, what time are we at now? 11, and we have until about 11:30, right? Yeah, so what I can do is answer some questions if there are questions that arose from my lecture just now. And then I wanted to do a little exercise where you might have to bring out your laptops and download a spreadsheet that's already available to you on the Google Drive under tutorial 3, we're calling it. Well, I'll double check the Google Drive if you don't mind. And I can also bring up the spreadsheet to describe what we're going to do with that in a moment. But I did want to check to see if there's any questions. I know I went through that very, very rapidly, so I'm happy to answer any questions. Sorry, I need to give you the mic.
Thank you, Alex, for another brainstorming session. My point of query is that, so for example, we as usually as a geographer went to fields, and in many cases, like issues like Sundarban, we need to ask questions which gives us result in binary terms, yes or no. Now, what to do with this binary data if we are considering to put them into the environmental quality index?
Yeah, that's an interesting problem. I guess I presume in some cases you might have multiple yes or no's. So then you could start looking at the relationship among the responses and maybe aggregate up responses across 3 or 4. But can you give me an example of a yes or no type question you might ask someone in the Sundarban?
Say, for example, if we go to a household and just ask them whether they have a gas-based oven or not, whether they use rudimentary form of cooking system, they will come up yes or no. We have a gas-based oven, or no, we don't have any gas-based. That will give us a sense of indoor environment within which they are living. and that can be put as an indicator for our environmental performance.
I would say that that could be used among a number of different household level variables that could, so you might be collecting data on things like if they're not using gas, then are they using, animal dung, or they are using, wood, mangrove wood, or some other wood source, or charcoal. And each one might have a different sort of potential harm to the population. Indoor air pollution is clearly one of the huge issues, particularly among women, for their health. So I think you might want to go beyond just that binary question, ask more questions. If all you were able to ask is that one question, then it could be combined with maybe a number of other metrics into something. I have to give it some more thought. It's a good question. Are there other questions related to today's lecture? Another question.
For imputation purpose, you have used MCMC model, that is Markov chain Monte Carlo multi-imputation. So if you look into the Markov chain model itself, it looks into the past data, present data to predict the future data. Now, if we do not have the past and past data, then how this model is going to work?
I think the MCMC method can be used in a number of different ways. I actually have some separate slides on the MCMC method, but I don't have them right with me here. And this is not a particular area of expertise. I tended to work with a statistician who worked with the model a lot more. My understanding is it can also be used so it generates multiple variants and using a number of data inputs. And I was under the impression it could also use correlates. But I'm going to have to go back to my slide deck and then talk to you offline about that, because it's a great question, but I don't have the answer. So I realized today's lecture was a little bit more technical in nature and maybe not as much, conducive to large discussion. But I did want to get it in, and tomorrow what we can do, I want to pull together some data and we can actually start working together in sort of developing, some kind of index framework on a state level. My hope is to do that for India. But today what I wanted to do is look at the implications of using arithmetic mean versus geometric mean for the HDI. So I put, hello? It's in the Google Drive, yeah. So there, in a lab, I think it's tutorial 3 folder on the Google Drive, you'll find a spreadsheet. And it's a Google sheet. Hopefully if you have your laptop here, you can pull it up. And I'll bring it up. I guess the best way is for me to bring it up here and describe a little bit. So what see if it's, all right, he's bringing it up here. So this is a relatively simple exercise, but what I want you to do is, sorry. So I want you to calculate, first of all, the geometric mean of, from which you need to calculate the geometric mean are life expectancy, the education, which is the average of expected years of schooling and the mean years of schooling, and then finally the GNI, the gross national product or income per capita. And so this basically is a function of these indicators. And then the arithmetic mean here is these three indicators added together. Then what I'd like you to do is sort. You've got the formula for calculating, basically adding the indicators together and dividing by 3. So from highest to lowest. So if you can just. And so here I'll take. You've been able to follow the steps thus far. Not terribly complicated, right? So it takes these 3. That's the way in Excel of doing the cube root of the value of the. You're basically adding the 3 values together. So that's the average value. And it does use the. I think I did the arithmetic mean minus the geometric mean. Let me double check on that. Sorry. What's that? Okay, let me see if that's true in my. Um, so I subtracted the arithmetic mean. Let me do it in the other way around. The geometric mean from the arithmetic mean. Wait a second. Just 1 second. So this is the subtract the geometric mean from arithmetic mean. I want to do it the other way around. So I'm going to do the arithmetic mean. Oops. Yeah, so if you do the subtraction in the other direction, you're finding that Pakistan comes out with a difference in rank of 7, is basically showing that if you take the arithmetic mean, Pakistan actually shows up better than it would have shown up under a geometric mean. And than it does in fact show up in a geometric mean. So that means that for one of these performance indicators here, Pakistan is lagging substantially, and it seems to be the education indicator. Okay, so that's one reason why the HDI uses a geometric mean, is to basically bring down the overall score of some countries where there's very high, uneven performance across the components. Some countries actually would benefit more from an arithmetic mean. In those countries, well, that I think Pakistan is a classic case, but there's others here. So a number of countries benefit from arithmetic mean. All of them tend to have relatively uneven levels across the 3 indicators. So what you want to do, why the HDI chose the geometric mean, in summary, is basically to penalize countries if they perform poorly, particularly poorly on one of those indicators, just to say. So that kind of, I think that brings us to the end of that particular exercise. What I'm hoping is that tomorrow we can spend a little time actually playing with real data and doing a bit more of this in class. And I can talk also a little bit more on, construction of vulnerability indicators at that time. Are there any other questions or issues, concerns? How to rank them? All I did was I basically sorted on the scores. So I'll just show you once again. If you hold my shoes. So what I did was I took the largest to the smallest score for HDI, and then I'll just delete these values. Yeah, well, oops, I just hit the wrong one. All right. So I then just I added 1 and I added a 2. And then Excel has a handy feature where if you just pull that down, it will just continue the ranking all the way down to 193. That makes sense? And you can do the same then if you sort for the arithmetic mean on largest to smallest, you can do the same process. So one of the steps that I did not cover in this particular exercise, and it's worth just exploring, is how they calculate the score for life expectancy to begin with. This is basically a min-max score. So let me just move over in the spreadsheet. What does this min-max score tell you? It basically says, you can just interpret by looking at this here, that the lowest score for life expectancy at birth is 20 years. I'm actually curious to know now which country it is, but we'll look at that in a second. But the highest score for life expectancy is 85 years. A min-max score is calculated as follows. You take the country score minus the lowest score in the range of all countries. So that lowest life expectancy is 20 years somewhere in the world. I'm not sure where. It might be Haiti or Niger or someplace like that. Then you divide that by the difference between the highest in the total range of scores for all countries and the lowest score, 20. Does that make sense? So basically, the score for Liechtenstein in this case is Liechtenstein score minus 20 divided by the total range, meaning the highest score for all countries minus the lowest score for all countries. And let's see where that country is that has a score of 20. There's no 20? Yeah, I wonder why they chose 20. This is basically coming right. What's that? Yeah, so I don't know why they chose 20. You could choose an arbitrarily low value, and that appears to be what they did. They chose an arbitrarily low value. Let's take a look at, interesting, in India, your commas go in a different location than so I'm a little confused, but this looks like about 146,000 for a country, for Liechtenstein. So let's see how they did this one. So in this case, what they did is they took the log, and that's written up in their material and methods. So you have the raw value here for Liechtenstein of 146,000 GNI per capita. So they took the log of that value minus the log of 100, and then they took the log of the highest value minus the log of 100. And I'd have to look into their material and methods a little bit more. They have a very detailed methods document to understand a bit better why they use this methodology, and why it's why the low value is 100. It may be that the lowest GNI is 100. I doubt that, but they also don't use necessarily the highest of all the GNIs. It might be the average of the entire series. Yeah, yeah. 690 is the minimum. Yeah, yeah. Yeah, I remember actually when I went back to the documentation, it was all explained in greater details. So I can put the documentation in on the folder as well, because we got a little tripped up as well when we started doing this to recreate the HDI. So one thing I'll just say in general, if you want to learn about index construction, probably one of the best ways to do it is to go back to an already constructed index and figure out how they did it using the same formulas that they used and try to reproduce what they did. So it's a good first step in kind of learning the process of constructing an index, is just following the methodology that somebody else used and seeing if you can reproduce it or not. So this was I'm glad for some of the input of the participants here, because it's very helpful. So I think with that, maybe we'll break. If you want to talk to me about any specific issues, or if you're having problems still, we can, we're having tea now, so feel free to come up to me with your laptop, and I'll be happy to walk through any issues that you may be having. So thanks for that, and I don't know, where's the tea? Still in the oil. Yeah, so we're going back across the courtyard. Enjoy the nice weather today. It's a little breezy. It's sunny. The blue skies. I love it. Uh, Building block, because you may have read one of the assigned readings, which, thank you. You may have read one of the assigned readings, which basically talked about, the fact that in climate mobility studies, part of the issue has been that researchers sort of started as if there were no prior theories of migration out there, and often they began from a kind of neo-Malthusian viewpoint, which is that environmental factors are the reasons why people are migrating, and that's all we really needed to look at. And obviously, we know today, and I think we knew then as well, that that's not enough. So let's take a look at this outline, which has to do with this, first looking at the scientific study in demography of migration, then looking at migration theory and climate mobility, and then finally, I want to get back to this topic of climate justice, which was begun to raise earlier, and see how it relates to theory as well. So population mobility is multidimensional and multifaceted phenomena with multiple levels of analysis, from individuals to households to communities, nations, regions, and globes, embedded in social and other contexts, and further defined by temporal and spatial dimensions. So that's what makes it somewhat complex to study. So how do we capture this multifaceted character of mobility and migration? So one way of capturing it is just to say, if you've crossed a national border or an administrative unit of any kind from one state to another in India, then you've migrated. That's one way of defining it. There have been other efforts to define minimum distances for migration. So if you lived on the border between Bihar and Uttar Pradesh, for instance, and you cross 2 kilometers from one side to the other, is that really migration? You could say that's just moving your house a little bit. So there have been other efforts to define things. IOM defines migration as the movement of a person or group of persons either across the international border or within a state. It is a population movement encompassing any kind of movement of people, whatever its length, composition, and causes. It includes migration of refugees, displaced people, economic migrants, and people moving for other purposes, including family reunification. One thing that this doesn't really incorporate is the temporal dimension, which I think is lacking. So if you're moving, we talked about, yesterday I was doing a separate lecture, but I talked about seasonal migration in India, and I'll present a little bit of that tomorrow. If you're moving seasonally, is that really migration? Yeah, it is. It's a form of migration. It's called circular migration, but people are not leaving, say, to go permanently to another location. So there's also in the literature a growing kind of list of different types of migration that are being described. Distress migration is considered to be a movement made in conditions where the individual and household perceive the only viable livelihood option for moving out of poverty is to migrate. Such distress is usually associated with lack of livelihood options, blah, blah, blah. So that's kind of the notion that you're not really you're not voluntarily migrating, you're moving because of some stress on your life. And there's a big debate in migration literature on what constitutes free will and the decisions. Like one person's choice to move could be someone else's. Like things are really so bad, they've gotten so bad, I need to leave. There's no other option. So volition is essentially underlying some of these concepts. Environmental migrants are generally people who move because of sudden or progressive changes in the environment that adversely affect their lives or living conditions. So they're obliged to leave their habitual homes. Mixed migration is a term that's being used increasingly. And here the idea is that people have different motivations for moving, but they're all moving sort of. So a lot of people are leaving different countries of the world, and they're crossing as undocumented migrants into the United States on our southern border. But there's really a mixed form of migration because the motivations, some are Venezuelans seeking, basically, they want to flee the Venezuelan regime because it's a very repressive regime in some ways, and the economy has completely tanked. Chinese, maybe things aren't so bad in China, but the Chinese are also moving across the U.S. southern border. But in their case, it's because, well, there's been a slight economic downturn, and there's a perception that America is a land of opportunities, and they want to go. So there's this people traveling together with a mix of migratory motivations, and then sometimes you know there are mixtures of communities migrating in the same direction. Um, so there's spatial and temporal concepts here as well as volition. So Beth Fessel, a colleague of mine at Brown University, has talked about 3 dimensions of migration theory: a spatial dimension bridging the origin and destination areas, a temporal dimension explaining why migration streams begins and continues to grow over time, a volitional dimension revealing the responses of migrants to the context that produce and change the migration system. So it's this is sort of one way of encompassing the different elements of migrants. So why does it occur? Why does migration between 2 places continue and maybe grow over time? For instance, South Asian migration to the Western Asian region is huge. The number of people moving to the Gulf for jobs and things, and it has grown over time. As people move, more people tend to move and follow them. We'll talk about that in a minute. Data and measurement. The major aspect of migration that separates it from conventional demographic approaches is the intrinsic importance of geography, meaning location. Handling time also raises some concerns for discerning whether an event has taken place or not. The measurement and analysis of migration also involves some specialized concerns in data collection and management. So it's unlike births, deaths, marriages, happens once, and you can locate the person in time and space. Migration is happening throughout a person's life course potentially, and you might measure at every census migration occurring in the 5 years before, but that gives quite a bit of temporal depth to, like, you don't know, there's uncertainty in when that person actually relocated if they say that they migrated in the last 5 years. It's even worse if you just use the censuses and every 10 years record that people have been moving. You don't know when they moved during that time period. So then there's kind of these flows of people and potential counterflows of things like remittances, money being sent back home. So there's a place of origin, a place of destination, and a flow between them. That's clear. But beyond that, there's also these counterflows. So as I said, flows generally are related to some administrative division. So you've got people moving from different administrative areas between them. And then this person technically would not be considered a migrant because they move within the same location, the same administrative unit. That would be considered internal mobility. So in an international migration system, there's internal domestic migration and external or international migration. So types of internal include rural, urban, rural, urban, international, cross-border. And these could be in some sense viewed as a progression of different types of migration. A lot of people now in the U.S. are leaving, Los Angeles, and they're moving to the middle of some rural area of Colorado to breathe the fresh air. They don't want to live in a congested area. And urban, clearly is more of a feature of places like India, where people tend to hop between major cities. You've got, anyway, these are all types: international, temporary, forced, voluntary. And then we've talked about the age selectivity of migrants. So typically, the probability of having migrated, in this particular graph, in the last 5 years before the census, shows that, disproportionately, like in Chile and in places like Panama, it's the young who are migrating a lot more. It looks like Nicaragua migration, rural, urban, and other types of migration is not very high, even among younger populations. This is the Senegal River Valley, and you get a sense of the fact that long-term migrations, again, tend to heap on the younger age groups. The shorter-term migrations and seasonal migrations are a little bit more evenly distributed across the age range. There's different sources of data to measure migration, census data on migrant stocks, where people lived 5 years before, et cetera. Survey data, where people lived 5 years before. That's a typical question in a lot of demographic and health surveys. Migration calendars is much more detailed, so you could actually sit down with people and collect when the events, like in their life history, they move from one place to another, and you can begin to build up a sense of when people moved. And that's also migration histories. Administrative records include residency permits, like in China. I understood here as well. Yesterday, I was talking to some people at the National Institute for Urban Affairs, and they basically said that I didn't know this, but in India, it's very hard to change your permanent residency. Is that true? If you're a rural dweller, apparently, like, you would be counted in the census based on where your home village is, not necessarily, all right? So that's one element. It's not that people don't move. We know that in China, many people move without the hukou. But what that means for them is that it may throw off official statistics, because the hukou would say, well, you're really still in the rural area, whereas a male may be living in Shanghai or somewhere else. What that means for the it prevents families from migrating generally, because you won't get access to schools, you won't get access to healthcare and other things, because your residency permit ties all of your benefits, your social benefits, back to your home village. And there's new data sources, including social media, big data, called detail records. Some of you may have an interest in some of these. Someone mentioned to me Facebook data, for instance. They're now being used for migration research increasingly. And some of these have strengths, but you also have to look at the biases inherent in, who's got access to telephones. Not everybody in low-income countries actually uses cell phones. Social media, even more biased, because not everybody's on Facebook. So here's some example of internal migration matrix in Antigua and Barbuda, and it basically talks about in the 5 years from 1996 to 2001, how many people moved from one location to another. So this is sort of a traditional, and these sort of matrices also exist. You can get matrices for the entire world, country to country, and there's a guy named Guy Abel, who spelled A-B-E-L, Guy Abel. He's done some really interesting work trying to harmonize, because these data, frankly, it's a mix of flow data and stock data. And when you're looking at those two types of data, trying to reconcile the stocks and the flows between countries is difficult. So he's used a number of different methods to come up with these stocks and flows. And then you can come up with total net migration. A net migration rate is basically the number of migrants divided by the population. And you get a sense that some parts of Antigua and Barbuda are losing population, and other areas are gaining population, like St. John's rural. So survey data example, migration calendars, rural East Asia. So this is an example of a calendar approach for an area in Southeast Asia. And you get the number of movers and the total number of migrants and moves. And then, so you can kind of tabulate over, a number of different migration, a number of time periods, the levels of circular migration in this area. This is an administrative example, so it shows how IRS data shows migration between locations. Let's just take an example. So this is in migrants and out migrants. So what happened in 2004, 2005 in New Orleans, Louisiana? Does anyone know? Probably not, but it's Hurricane Katrina was a major event so what you saw was massive outmigration out of New Orleans and massive in-migration into other places, including places like Florida. And then you have some areas, Kings County, New York is actually Brooklyn, I believe. And so you've seen, during certain periods, out migration out of the area over periods of time because of economic downturns and the like. This is an example of use of cell phone data in Bangladesh. You might have seen this article before, but they use cell phone data to understand movements of populations just prior to cyclones. So a cyclone warning occurred, and did people move out of the area to get to a safer place? Some of these would be like chars in the on the kind of Ganges Delta, very low-lying areas, and the idea was that people should, in principle, be leaving those areas. Direct methods are based on explicit questions such as place of birth, place of previous residence. Move-ins are estimated by comparing the location of an individual in 2 points in time one and time zero. It may not be possible to know other movements during the interval between the two dates. So like I mentioned, if you measure what happened in the last 5 years, did you move anywhere, you're going to only generally capture one movement, not multiple movements. Indirect methods, you can look at the residuals. So this is an example that I mentioned of using the population balancing equation, where you take the population in time one and take the population in the period before that, and you look at natural increase plus net migration. But you can back out net migration by taking the population change and subtracting out natural increase. We did this actually on a fairly large scale for this project for the UK Foresight report on migration and global environmental change, and ended up publishing some of the results here in this journal article. What we wanted to do and what we did eventually achieve is getting a map at a 1 kilometer basis of net migration for every 1 kilometer grid cell globally. But all we had in hand, the only thing that we had at the time we started this project, was population by decade. So we had 1970, 1980, 1990, 2000, 2010. At the time we did this work, 2010 was actually a projected population based on 2000 census data. And what we did was we measured, and I'll show how we did it in a moment, but what we were asked to do by the UK Foresight Project was estimate the number of net migrants per decade from 1970 to 2010. So this is the first decade. The next one is 1980 to 90. You can see the beginnings of a fairly large migration out of rural areas of India towards cities, out of Western China towards the coast. It accelerates in the 1990s, and then in the 2000s, it sort of evens out a bit. And this is partly based, we didn't have the 2010 census data at the time we did this work. So the approach was, as I mentioned, to take the population balancing equation and use that to calculate net migration. And what we had was population growth. It was easy for us to subtract the population grids from 1970 to 1980. So, 80 minus 1980 minus 1970 gives you the population change per pixel, right? That gives you the total population change. But what we needed was to remove from that what we estimated to be the net natural increase. Because if you remove the natural increase, the burst minus the deaths in that pixel, then you can get the net migration. So it's an indirect estimation approach. So we could have just used country level rates of natural increase and applied those country level rates of natural increase, births minus deaths, to the whole country. But that wouldn't have given us any sense of where natural increase might be higher. Where in most developing countries would you expect natural increase to be highest? No, I'm actually just referring to, I'm sorry, the parts of the country. So would it be more rural or more urban? Yeah, rural areas we see much higher, right, natural increase than urban areas. So we actually compiled as many rates of these are crude birth rates and crude death rates. So that's births per thousand and minus deaths per thousand. And we were able to look at, so we got the rate of natural increase by taking the crude birth rate minus the crude death rate. And what you see is if every country had basically equal levels of birth and death rates across the whole, if they were equal everywhere in the world, they would be all around an identity of one, right? Birth dates and death rates basically equal to each other and balancing out. But what we actually found was that there was much more variation in the crude birth rates and death rates. So the ratio of urban, I'm sorry, this is a little bit, the graph here is showing the ratio of urban to rural rates of natural increase. So if they were equal across a whole country, you'd expect them to be equal to 1, right? The ratio of the one to the other would be 1. And so what you actually see is the ratio of rates of natural increase in some parts of the world, limited parts of the world, are actually higher in urban areas than in rural areas. But for most of the world, they're higher in rural areas than they are in urban areas. So we needed to create basically a grid on a 1 kilometer basis globally of rates of natural increase that we could then multiply by the population to get the change in population in that decadal period due to natural increase. And to do that, we collected as many data as we could get on rural and urban differences in rates of natural increase. And we compiled those crude birth rates and crude death rates for 5,000 country year observations, and we imputed the remainder using 2 different statistical packages. One was MI and the other was Amelia. And so we worked with statisticians to do that. And what you see basically is in some countries, there's the rates of natural increase were lower for urban areas. Let me just make sure I'm right about that. So this is China. So rates of natural increase were lower in urban areas than in rural areas. But in the U.S., it's the opposite. Actually, the urban areas have a higher rate of natural increase than the rural areas. So we were able to use this relationship in a generalized relationship. We just created a linear, basically regression. And depending on your level of urbanization, the degree of urbanization, the population density in essence, we were able to calculate we were able to impute, I should say, the rate of natural increase for that particular grid cell. So here again, the approach was we needed rates of natural increase that varied subnationally, and we just took urbanization in a sense as a proxy, but we used the actual differences in the rates between urban and rural populations in the country to impute the level of rates of natural increase. So finally, we came up with this. We were able to subtract out the rates of natural increase on and basically the population increase that was due to natural increase, and from the difference between the 1980, or in this case, the 2010 and the 2000 census, and we were able to come up with these maps of natural increase. The method has been replicated by other groups, but it just shows that you can do some kind of interesting things when you understand the relationships between the demographic variables. One kind of interesting, this is a parenthetical note, but it's about what we see about the change in population due to net migration in different parts of the world. And for dryland ecosystems, we see for every region, Africa, Asia, Europe, Latin America, and Oceania, we see declines in or negative net migration, meaning people moving out, often very high levels in China, especially, but also in India and other countries. But in the US, we have a counterfactual with people moving into dryland ecosystems, and that's a net migration largely due to amenity migration. People like those dryland areas in the southwest US and in California. The same is true for mountain ecosystems, massive outmigration over each decade in Asia from mountain ecosystems, and a lot of migration into mountain ecosystems in the US. So we are the outlier. Canada maybe also as well in that case. What you do see consistent across the globe is a lot of migration into coastal areas. So everybody seems to want to live near the coast. Those are areas of economic dynamism. So that's just an interesting sort of side note on how to use available data to produce estimates of net migration. Like I said, that particular approach has been replicated now by 2 different groups with some slightly improved refinements to our earlier method. Rates show the relative frequency of a type of migration or mobility. So this is an example of a rate. Residential changes in area over a period of time with MI being what again? Minus period population of the area. So I should have looked at this slide earlier. I'm sorry. I don't remember what the MI stands for. But you can look at rates of migration based on essentially the levels of population that exist in the area. And so this is net migration per 1,000 population by country and territory. And it shows areas where there's very strong negative net migration out and positive net migration into different countries. This is sort of stands out here. Which country is this? Does anyone know? Venezuela, good. Yeah, so Venezuela, as I mentioned, has seen political crises. These countries here, I think South Sudan, and I think that Central African Republic have seen massive, it's coming back up, massive levels of outmigration due to conflict for the most part. All right, so that's all. How do you measure migration? Let's talk now about migration theory. And the theory answers questions like who, what, why, when, where, and when. This is a paper that you have been assigned, and some of you may have read it, for which you are to be commended. But it's a paper that talks about migration theory in the context of climate mobility. And it basically, we say that migration theory in general helps to contribute to our understanding of who migrates, why they migrate, the types of mobility they employ, what sustains migration streams over time, and why they choose certain destinations over others. So at a most basic level, I really like this guy, Jürgen Carling. So if you ever have a chance to read any articles by Jürgen Carling, I find him one of the most helpful theorists. He's really the father of what we call aspirations and capabilities, and we'll talk about that in a moment. But Jürgen Carling, by the way, when did we start the lecture? Does anyone remember? No. Was it 12? Okay, close to 12. So Jürgen Carling says, ask the basic foundational question upon which all theory is really based, or all theory is trying to come to some understanding of this, is why do people migrate? And he basically, in a very commonsensical approach, says, well, people migrate for reasons under which they are admitted as immigrants or asylum seekers. So if you know that you can go to the US and claim that you're a Christian and you're being persecuted by some other group in your country of origin, you'll have a higher probability of getting admission into the United States than if you claim that you couldn't get a job or whatever. So people often adopt those reasons for migration, and then that becomes their narrative. I moved because of this why, even though economics or other things may have been underlying that. They also move for reasons that are socially legitimate. So in certain cultures, it's okay to say you move for educational reasons or something, but it might not be so good to say that you couldn't get along with your in-laws. You hated your mother-in-law. You just wanted to get out of that area, right? So let's just be honest. People give lots of reasons, and if you go to someone and you ask them in a social science survey why they moved, they're going to give you a reason. Well, you better understand that there may be socially acceptable and not so socially acceptable reasons for leaving. For instance, if you're a young Ukrainian male and you happen to leave Ukraine around 2021, do you think you're going to say, I left because I wanted to flee the conflict and avoid being drafted? Yeah, that's not really socially acceptable. In the Ukrainian community, you'd be viewed as what are you, a traitor? So again, you need to kind of take these things into account. So they might, they say, well, I have a job that's vital and important and I need to survive in order to support my mother who's 85 years old and, whatever. And so those are things that are socially legitimate. Another reason is because the sum of push and pull factors in favor of migration. And one of the things I like about Carling is a lot of sophisticated, really highly intellectual people say push-pull model. Going back to, Lee, who was one of the fathers of the push-pull, and we'll look at that in a second, that's just complete nonsense, and, we should discard that in favor of much more theoretically complex explanations. But he comes out and says, well, actually, yeah, there are reasons people are pushed out of certain areas, maybe economically deprived areas, and are pulled to more vibrant places. And let's just be honest that there's often that push and pull does in fact play a role. He talks about aspirations and the ability. So we're going to talk about aspirations and capabilities more in a moment. He talks about opportunistic reasons. My cousin, he was going. He said, I've got an extra seat. Why don't you come along? It's true. It happens like that. And it's like in many parts of the world, it's like, well, if I don't leave, I may miss my opportunity, and I better go, either because they choose to or because they are forced to. And this is again getting to volition, because they see migration as either intrinsically or instrumentally valuable, meaning migration can become an end in itself. That's captured in some surveys when you ask the question, did you leave in part because of adventure or a sense of like expanding your horizons, right? This idea that many of us have, I had as a young person. I went to the Peace Corps because I wanted to see the world, right? I didn't want to just be stuck in an office somewhere in Boston or New York. I wanted to go out and see things. So that was a reason for me to, quote unquote, migrate, I guess, over to Mauritania. And then another is just to lead a normal life, which I find very interesting. He gives examples of quotes from surveys and stuff where, if you talk anecdotally with people that say, well, we left because, everybody was having vacations and like, that's just a normal thing, right? To have a vacation, but we never had a vacation in our life. So we aspired to have like a normal life, which is maybe to take a break every once in a while instead of working every day of the year. I want to get away. So things like that, people consider where they're living, they can't lead a normal life. Sorry, so I went on a little bit too long on that one. But so this is an example of work that I've been doing with a colleague who's a demographer, Susanna Adamo. We haven't published this yet, but we hope to get it out soon. And what we did was we compiled all the surveys we could find for Central America And all the surveys that we could find in West Africa, these are surveys of migrants. For the most part, the way they're conducted is a migrant is, you go with your survey instrument and you find the migrant and you say, of these 10 reasons, which reasons would you say that you chose to migrate? And it's not exclusive. So you could move for economic, and you could say, I also move for educational reasons. So they check, and then they sum up all the migrants that have responded, and they come up with some percentage of migrants that have said one reason or another. That's mostly how they're conducted. There are a few migrant surveys where they also say, what is the primary and number one reason that you left? And then they might come back with a second round and say, well, what other reasons would you have? Which actually muddies the waters a little bit. So it's harder to compare those surveys with the other surveys. But what we found was, of course, for almost pretty much every low-income region you're going to find is that economic reasons and pay and often things like sending. This happens to be a difference. So in West Africa, you see a lot more migrants saying they want to send money home, because of social ties. So in Central America, it's not that sending money home is not important, but it is not nearly as important as in West Africa. Again, that's a socially acceptable reason for leaving. I want to send money to my family that's left behind, and people will accept that, and it's sort of legitimate. Or it's considered a legitimate reason. Corruption in governance shows up a lot more in Central America. Violence and insecurity also much more in Central America, whereas violence and insecurity is, around about 17% here. It's over 22% in Central America. One of the things that's happening in Central America is there's a lot of narco trafficking, so there's increasing disruption of normal life as it were, in that region because of the effect of this huge influx of money. It's also leading to a lot of corruption because government officials are also taking a cut of that huge amount of money. And so it's a very messy situation there. And so that's reflected in a lot of the responses that we get. But what you also find is that the environmental component here tends to be very, very limited. And so we, as climate migration researchers, often want to think that there's a much more importance to the environmental stressors. Migrants will mention things like back to the hurricanes that occurred in Central America. They'll mention things like drought. They're certainly important. And part of the issue may be that they don't necessarily tie the environmental stressor to things like their livelihoods, okay? So they're poor, but they don't necessarily say, I'm poor because, in partly because there's been repeated droughts or cyclones in my area. But there's different reasons. So theories are critical for understanding processes we observe in human nature systems. And I said earlier, when we did the causal modeling, that we all carry these models in our head. We all think about things and we all frame things in certain ways, but it just helps to make explicit what we think. It's another thing also because theory, if you're going out to the field, and I've talked to many of you, you have gone out to the field or you're planning to go out to the field. If you don't have a good framing and a clear and explicit framing and theoretical background, it's, you need it in part to shape the questions you're going to ask. But you also have to be careful. So if you go with a gender theory and say everything's about gender and gender, then you're likely to just find everywhere you go, it's the lens that you're looking at everything, and gender is going to be the most important thing. Where it may be, but I'm just saying you have to be open to the idea that there may be other factors other than say, gender in that particular case. So again, it points to a specific location for research. It influences what researchers find. If you, like the common saying is, if you think you're going to find something, you're likely going to, you're going to go out and corroborate what your predetermined idea is. So we should try to use theory as much as possible as ways of kind of broadening our view as much as possible, not limiting it. And as I mentioned earlier, a lot of the stuff that's been done early on in my climate migration research was very much influenced by this neo-Malthusian view, where, where migrants are hapless victims of the environmental change that's occurring. So traditionally, migration theory has been broken into two components. One component is mostly these individualistic kind of theories that are focused on the neoclassical Homo economicus wage utility theory, where you go to the place with the highest wages, but you also have to take into account intervening obstacles and things that might come between you and the ability to achieve that higher wage. But that's the sort of functionalist school. The other school is more structural theories. And you might have heard of the world systems theory that Wallerstein came up with. Their dependency, structuration, dual labor market, all of these emphasize there's an enormous wealth and power differential between the first world and the third world, or the low income. That was the terminology used in the 70s when a lot of these theories came about. But the global south has a low degree of autonomy and suffers from a neo-colonial impediments, which results in poverty. And then the north has high labor demands because of its industry and its service sectors. And so that, even though we tend to restrict migration, we we do need a lot of labor. And so that's the sort of paradox. Aspirations and Capabilities seeks to thread the needle a bit by recognizing individuals to migrate while there are structural factors that impede people from migrating. So a lot of this stuff, though, can go all the way back to the 1880s, much like climate science can be traced to those early pioneers. Ravenstein had this theory, and it makes a lot of sense even today, that most migrants proceed only a short distance and towards centers of absorption, meaning urban industrial centers. As migrants move toward absorption centers, they leave gaps that are filled by migrants from more remote districts, creating migration flows that reach to the most remote corner of the kingdom. So, I saw that in different parts of West Africa, where even in poor rural areas, there's always someone who is a little better off, maybe a landowner, and they would employ laborers from a neighboring country, and those people would come and work on the fields. Each main current of migration produces a countercurrent. Migrants proceed long distances, generally go by preference to one of the great centers of commerce. So all this still has, some resonance today. This is the push-pull theory, and the idea is that people are pushed out of areas because of poverty or other factors, and they may be pulled because of attractive mix of factors over here, not just jobs and economic opportunities, but maybe services, education, etc., schools. Parts of Ethiopia, for instance, they don't even have schools in a lot of, at least high school level. You have to go to a larger city or town to get into high school. So people move out of the origin area, they go to the destination area, but there are a lot of intervening obstacles, and those things include distance and cost, policies that might restrict migration, visas, and border controls. In the 1980s, there arose this new notion of new economics of labor migration, where it's not so much a decision. Deciding to migrate is not so much one's individual decision, but rather a household collective decision. The idea is it's a risk reduction strategy. So in the climate mobility space, this is one of the most widely cited theories, because basically what it means is that you've got these benefits, remittances back to the family of origin in the village, remittances to invest in agriculture and other additional livelihoods, so setting up a little shop, fewer household members eating scarce food reserves, and diversification of income together with an insurance risk reduction approach. So if you don't have insurance, this is actually a pretty good bet. It's a popular theory, and it can be coupled, as I mentioned, I talked about the various livelihood capitals. It can be coupled with that livelihood approach. Then we had already talked about this, and I'm not going to repeat what I said about the demographic transition here. But just to say that one theory is that there is what's called a migration hump. And the idea is that when you're in very low income conditions, migration is very low. But when you start getting increases in income, you start to see more and more migration till a point where a country might actually start becoming so well off that people don't need to migrate anymore. So this is one of the challenges where, let's just put it this way. So a lot of developed countries are thinking, well, the way to increase the number, to keep people in place and to avoid people migrating to our country is to help develop their economies, and in the area of climate space to help with adaptation and things like that. But theory predicts that if you add $1 to someone's income, the propensity to migrate actually increases by a certain proportion. So, not just $1, but $100 of income may yield an increased probability of migrating up until a certain threshold, where at which point people stop migrating. So that's the idea of the migration hump. I already went through all of this before, but these are the different phases of the mobility transition. Some other theories out there are theories of sustained migration. These are theories that basically explain once a migration system is in place, why it perpetuates. So in South Asia, we see a lot of migration to West Asia. And once that began, it got sustained over time as the economies of West Asia became more and more dependent on labor from India, Bangladesh, Nepal. And the families and the social systems in the sending areas of South Asia became more and more accustomed. And I'd love to hear more discussion of this particular phenomena during the end of the lecture. But it's certainly a phenomena that has explained a lot of migration in many parts of the world. And one question for each of these theories is, how might environmental factors fit into this? You could see ways in which migration systems could be affected by climate change in different ways, by making places more or less desirable to go. Life course analysis is largely limited to the demographic study of migration, and that's really about how migration is more characteristic of certain life stages. I like this concept of imaginaries, and that's really about, in my view, it's about perceptions, cultural norms, and expectations. And it's kind of like, did anyone see this movie? It was very popular. Well, it won a Cannes, and it was even nominated for the Academy Awards. It's called Il Capitano, and that means the captain in Italian. But it was about these young boys in Dakar, Senegal, and they're imagining life as superstar rap singers in Europe. And it becomes a whole it was a motivating factor for them. They needed to get to Europe because they wanted to achieve this dream of being superstars. I like this work very much by Fresnova Flott, because what she does is says, okay, there's these basic theories out there: neoclassical, new economics of migration, structuration, integration, diaspora, etc. But in the middle area, in the very center, is what goes on within people's heads when they're thinking about migrating. And I think there's one more diagram here. So these all emphasize rationalities, whereas these are more in the emotional and cognitive and kind of behavioral dimension. And at the very heart of it is the individual. And these are all things that may facilitate migration. We haven't talked about it, but smuggling networks exist in the world, right? So there are groups that actually actively promote migration and profit from it by charging people. And so social networks, social media, where people who left a country project success, and then everybody who, the young people who stay in the country say, well, they made it, I could make it too. So these are all things that kind of are external to the individual, but within the individual, there's all these things related to their relationships within the family, their desires, their feelings, their imaginaries, etc. So I already talked a little bit about this review of the literature we did on how migration theory was treated in different studies, and that's a bit of the rationale for why we did it. We did a total sample of 75 studies. We broke them down by different types of studies that used different types of data. So we had some that used census and survey data that were for other reasons, but they had questions on migration. We did some where there was just a survey that related directly to migration, and we did some where qualitative field studies were conducted with participant observation or interviews with people who had migrated or families that were left behind. And some of them focused on things like cyclones and extreme heat. A number of them had sea level rise, and others talked about other things like temperature, precip, etc. This was the regional breakdown. What we found was that the the most widely used theoretical framing was the new economics of labor migration. And then there are other theories beyond that, environmental migration frameworks, and then neoclassical was an important one, particularly among economists. And we did break it down by different types of disciplines that are doing the study. So sociologists and demographers tend to prefer the new economics of labor migration. Geographers really tend to emphasize other theories, and those theories are listed in the reading that article I mentioned. And then they also like things like the foresight framework or other environmental migration frameworks. And then, of course, economics, they're really happy to work with the neoclassical wage differential type theories. Then you have all these people who are in like totally different fields like computer science and modeling, and they like the push-pull model because computationally it's very easy to talk about numerical measures of push and pull factors in a numerical model. So I think I'll skip this and just see. I think, yeah, we're running out of time. So I mentioned aspirations and capabilities. Here we can talk about, I talked about acquiescent immobility yesterday, but essentially this is over here, and this is essentially people who have low aspirations and low abilities will be in this quadrant. They can't really move. People who have low aspirations but high capability to migrate. These might be people who we consider to be moored in place, meaning mooring like a boat is moored in a harbor, and they really like to stay where they are because they're happy there and they have what they need. And then you have the high aspirations, the people who really want to move and they're aspiring to leave an area, but they're involuntarily immobile, meaning they can't, they have no capability. And then there are those people who want to leave and also can leave because they have the means to do so, and they're the ones who are voluntarily mobile. In this, you can then bring everything together and look at, in a climate change framework, how climate impacts both aspirations and capabilities in different ways. Like in theory, climate change could block your ability to move if you're actually impeded from moving because the road is washed out, or there's some other, at least temporarily, you're unable to leave because of climate-related disasters. But more typically, climate-related factors will affect one's aspirations to go or to stay. And here are some of the potential the responses to each type or category that I mentioned earlier: voluntary mobility, voluntary immobility, etc. I'm going to skip these because we've kind of covered them earlier, and they're a little complicated. I want to touch briefly in the last part on climate justice. By the way, when are we supposed to end today's lecture? 1:15, right? Thanks for keeping me. on target here. I didn't set my timer, so um, so um, so just one other. So this is kind of ways in which, just to say that there are ways in which climate factors are being brought to bear on theory, and people are using it in different ways. I've already covered the hazard risk framework, but as I said, you take that hazard risk framework and you basically look at, situations in which people are immobile and they're trapped in locations and it increases their risk and therefore it's a bad outcome, versus situations where people move but they also get into locations where risks are enhanced, and so that's a bad outcome. And the only really good outcome is where you have either successful local adaptation or people move and they move to a better location, a more safe location. I'm not going to go into this so much, but this is sort of talking about voluntary migration versus displacement or involuntary migration, and the fact that sometimes people fail to reach their goals, and so they might go permanently or they might go temporarily, and they go back to their home area afterwards. All right, so let's switch to this topic of climate justice and climate mobility. So this topic obviously can link very clearly to structural theories such as world systems and dependency theory, where these theories tend to put less emphasis on the individual decision making and more on the structural economic factors explaining migration. So, I talked a bit about Wallerstein's theory earlier, and he basically had this idea that there's an unbalanced world economic order divided into core states and peripheral states. The peripheral areas have a low degree of autonomy and face potentially a kind of neo-colonial situation. So the theory suggests that migration flows are motivated by the unequal distribution of wealth between the rich core and the poor periphery. One of the conclusions from that is that international migration is influenced by this historically formed macro forces is inherently exploitative and self-perpetuating and leads to underdevelopment in the migrant source areas. So this is a negative view of migration, which is essentially one which migrants may benefit temporarily. There may be some benefit to the migrant individually or in their household from migrating to another country, to, let's say, from South Asia to UK. Let's just as an example. There may be some benefit to the individual and the household, but as a whole, it actually deprives India of brain power, right? That's a brain drain hypothesis. And the remittances that India receives back doesn't compensate for all the other negative impacts. And it's essentially an exploitative system. And part of the argument among people in this is, you're happy to take our goods, our natural resources. I was talking to someone about spices earlier, the spice trade, right? It's been important all these years. But you're happy to take our goods, but you won't take our people. And this is one of the complaints that many countries have, I think, legitimately about the world order. So I, mentioned earlier that I have a project that looks in comparison to Central America, between Central America and West Africa. Both of these regions have certain narratives that have been generated about the impacts of climate change on the populations in those areas and in the ways in which, and the strange thing is they take these pictures and for all we know, these people are going to a rock concert or something else, so there's that sort of objectification of people as well in the photography and the choice of imagery. I got taken to task when we were working with the Groundswell Project in the World Bank. Some of the imagery that they chose was similarly perpetuating these ideas, and I think it's something to be really worried about. So this is the Groundswell work that I mentioned just now, but basically, what we were doing was projecting internal migration within countries, but some of that work was, perpetuating a narrative of people, scraping together money to go and to take their chance to get, to get somewhere better. And I think that some of that question, some of that narrative may need to be questioned increasingly, and we have to think about ways of changing the narrative a bit. What I found in reading deeper on the motivations in places like West Africa is that climate factors are generally one of a mix of things, but they're rarely the most important, and they're very frequently not mentioned by migrants at all. The prominent ones are economic, followed by widespread pessimism about a system that doesn't exist to support them. So we talked about systems already. So economic systems are important, as well, in the way that systems kind of act to keep people in place in their place. Economically is something that many migrants know intuitively that they don't really stand a chance of, even with education, they don't really stand a chance in their home country of improving their lot. There's also issues of fear and insecurity in some parts of the world. So in both regions, the poorest generally lack the means to migrate across borders. Some become internal migrants, and some are involuntarily immobile. But another factor is governance issues. So what you see here for the UNDP, they did a report called Scaling Fences on African migrants to Europe. They say the core message from this study is that migration is a reverberation of uneven development, and particularly of a development trajectory that is failing young people, and sends a strong message to policymakers. And so a lot of migrants in this study, for instance, cited the fact that they felt that even with an education, there were so few jobs for them in their country that they and that those jobs typically went to well-connected, better connected elites. So let's take a look at framing climate mobility in a climate justice perspective. And this is one paper that I commend to you if you're really interested in this topic. The author's name is Carmen Gonzalez, and she looks at climate change, race, and migration. And she talks about, takes an explicitly racial justice lens for looking at the topic. And she talks about carbon capitalism, which basically, carbon, the pursuit of fossil fuels has led to, invariably to a lot of tragedies in many parts of the world. The Niger Delta is one example that's experienced this resource curse where it's become increasingly polluted as a result of fossil fuel extraction. And she talks about a slow violence of the unequal burden of extraction, processing, transportation, refining, and combustion of fossil fuels. She further talks about this idea of sacrifice zones. These are zones that carbon capitalism deploys race and racism as techniques of exclusion and control, creating regions that are expendable, geographic regions that are expendable. So there are parts of the U.S. even where parts of Houston, Texas, there's a community, a town called Perth Amboy in New Jersey, and the smell of oil refining and other chemical industries going on in those areas mean that basically, it's only the poorest people live in those areas. Finally, she talks about an abyssal line between those demarcating people who are presumptively entitled to liberty, equality, and autonomy from those relegated to zones of violence and dispossession. So this is really strong language, and if you're interested in the topic, I suggest you find this article. I'd be happy to send it to you if you can't get it. But one metric of this is something called the Passport Index. I don't know if you've ever seen this index, but it's basically how much your passport enables you to travel to other countries around the world. And, for the U.S., we've got a very strong passport index. We can go pretty much anywhere, and we're entitled to come and go as we please. We need visas for some countries like India, and but I can get into Europe, no problem. I just get on a plane and I go, and other countries require, extensive vetting and visa processes. I was talking to Professor Rahman. I invited him to a conference that we had in the U.S. in June, And he said, look at it, I don't have the time to deal with the U.S. Embassy. It's just too time consuming to try to get a visa for a one-time entry. So this passport index, basically places like Niger, parts of the Sahel, some other countries where there's a lot of violence, the passport index is very, very limited. In other words, you can't enter into anything but maybe a few neighboring countries with your passport. There's also this notion of common but differentiated responsibilities, CBDR, and so this principle imposes a common obligation of all states to address climate change while taking into account each state's contribution. So under this, in theory, the U.S. should be a global leader on climate, and we're falling well short of our obligations. But this is another principle. So Carmen Gonzalez ultimately divides up different types of responses, policy responses to climate mobility, based on whether they fall into a national security paradigm, more of a humanitarian response, or a migration management response. The national security one is basically guns and borders, and we're just saying keep people out. Humanitarian response says, oh, we're so noble, we're going to help all those people who are displaced by this disaster or that problem, but it doesn't really address the underlying root causes. The migration management response is much more about, hey, you guys are empowered, this is migration as adaptation, you guys are adapting, you're doing a great job, and we applaud that effort, and it shows how you're really kind of entrepreneurial in your approach to moving. And she sees that as also a trap in a way, because it basically suggests that families and households in the global south should figure out things for themselves. She proposes a self-determination, a just approach, where collective right of displaced persons to self-determination and legal continuity is self-governing communities and the ability to move. And so she would adopt a more open borders approach to the issues. So I think it's important to think about how the framing of even the policy responses implies certain things. The last few slides have to do with different elements of justice. Perhaps you've heard of these terms: procedural justice, restorative justice, and recognitional justice. What we do in this paper down here that's coming out soon is basically look at each of these justice concepts in the context of migration, and particularly environmental migration. And I think I'll maybe go through these while we take a few questions. But I see we have like maybe 7-8 minutes left, so I can flip the slide in a moment and go to the next one. But why don't we go ahead and take any comments or questions that you might have?
Thank you, Dr. Alex, for your nice deliberation. I have actually a query. Okay, what, in your opinion, to what extent should climate-induced migrants be recognized as refugees under international refugee law? Okay, so
Yeah, maybe take one or two more.
Thank you for this info-led presentation. I have few questions that I would like to frame as quickly as I can. The first comes out of this theoretical framework. What I would like to put it in the maximalist versus the minimalist approach. So if I try to go through the literature, in most of the time, what I find that people feel comfortable in writing in terms of minimalist approach, which actually sideline the idea of climate migration or direct. Like one of the example is of Lisa Otto, her chapter in Cambridge Handbook. She works on Maldives and she says like most of the students are taking education visa to other country because of climate change, but they're not actually agreeing to it, but they want to settle down to other places. The second thing is that why is it that we don't consider climate migration as the climate change migration? What I want to quote it here is like you must be knowing about COFA, Compact of Free Association of US with Micronesia, where they take refugee from Marshall Island, where they have tested nuclear for I think 1072 times, but still they are not being called as climate change migration a migrant. Instead, they are being drowning on that. So that's the other thing. The third thing, like including these things, how do you think it's like when it comes to imaginary, especially to global north, like what I consider in Edward Said terms as imaginative geography, this Dutch securitize, and what only becomes the possible thing is the marginalization and exclusion.
Okay, so that's three questions in one. So I'm going to start with these two, and then we'll keep going around the room. I'm sure we'll have some time too over lunch. So your question, what were the two words? Oh, under the Refugee Convention, yeah. Well, this has been hotly debated and written about at large, extensively. The international refugee agencies like UNHCR and other groups don't want to expand the definition of refugees because it's already what they see as countries like the U.S., for instance, are already failing to adhere to the minimum standard of people leaving their country for reasons of race. Creed, color, some political views and things like that. So they're not. They're really scared about opening up what could be a Pandora's box of, and then it's also hard to prove that someone actually, unless they were directly displaced by a disaster, it's kind of hard to prove it in some cases that someone is really moving primarily for climate reasons. But it's mostly legal reasons on the behalf of the refugee organizations. They don't really want to open that up. You talked about minimal and maximal approaches. So I think what social scientists often, I won't say it's a trap, but I would just say that we want to split hairs so much over that we often want to distance ourselves from what is viewed as commonsensical views of things. And so I think there's a little bit of that in the idea that we should just always err on the side of saying that climate factors are not important or are less relevant than other. Now I think they are generally currently today stated in the order that I showed that chart. They often very much are at the tail end of reasons for people leaving. But what we're not really always taking into account is the physical science basis and the future physical, the ways that climate change may dramatically alter habitability in certain parts of the world. You had a couple other. Can you give me a couple more keywords on things? Yeah. Yeah, well, I don't know a lot about that. I do know that there's been a compact for a long time. I know that Federated States of Micronesia, there's another Marshall Islands. There's a few that have this agreement. And yeah, I'm sure some people are leaving for climate reasons. And was there one more? Yeah. Yeah, it just perpetuates the problem. So that's a valid comment. Yeah, I saw a hand back here. Did you have your hand? So I'm trying to do it in the order that I saw the hands. So we'll take your question, then I'll go to the front row.
Thank you so much for the presentation, Professor. So I wanted to ask, do you think we can establish climate justice without epistemic justice? So to put it differently, when we often often the climate-induced displacement happens, people do not really phrase it in terms of climate, but other changes, which is generally linked to climate change. When we link it to climate, are we not shifting the blame from social systems to a scientific understanding of cause and effect as an end to all miseries? Through this, are we not keeping the people most affected by it outside the discourse which affects them?
Well, yeah, I mean, I think this gets back to some of the points I was making earlier in earlier this week when I was talking about the construction of social vulnerability and how we need to look at the economic systems. So I think part of the point you're making is there's a blame shifting that's going on globally, which kind of says climate is to blame for all these problems, whereas it's really the social and institutional structures. But I'm not sure if that's your main point.
I want to say the language of the way science communicates. So it keeps the discourse, the language in which often the common people getting affected by it communicate outside the discourse of science itself. So they can never be part of the scientific discourse because the language is different. So there.
Yeah, well, we do have a different, like I said earlier, we have scientific definitions of some of these terms and then the commonsensical definitions that people employ. So there is a way in which, common understandings are downplayed or deemed less significant. But I'm not sure I'm quite getting at your question. I'm going to have to keep going, though.
Thank you, sir. I have an observation. We fairly talked about climate mobility or climate change induced migration. But when it comes to this, it's mostly a phenomenon of the affluent population. Not necessarily socioeconomically affluent, but physically affluent, demographically of affluent, like the working population or the younger population, or intellectually affluent people, or per se. But there's a fair part of the world population which is probably scattered across the world, which is particularly third world countries, and even in the first world countries, there is a population which is inherently under the effect of climate change, pertaining to the involuntary immobility or acquiescent immobility which you talked about. So sir, this kind of population, it may be triggered by a socioeconomic factor, or senile population, or people stuck in war zones or conflict areas, refugees, or it may be in the developed world. We see there is especially abled people or people with various comorbidities, dependencies, emotional dependencies, and all of that factors. So when it comes to climate change migration induced risk prone zones mapping across the world, I think as important is the aspect of climate mobility. Similarly, the equally important is the aspect of involuntary immobility, which is the high risk prone population when it comes to bearing the brunt of the climate change. That was my humble submission. Thank you.
Well, you bring up a good point, and I hate to say another journal article, but there is another one that we just published recently that talked about the critical aspect of involuntary immobility, and I'll talk more about that maybe tomorrow.
Thank you, sir, for your nice lecture. Sir, I have a question. You have talked that the climate change impacts subsistence farming. So, sir, in India, we have lots of people dependent on subsistence farming. So, sir, what can we do to reduce this effect?
So they're living on
impact of climate change on subsistence farming.
Oh, yeah. Well, this is something that you bring up and I'll come to you. I will come to you. But tomorrow, what I want to do, we're going to have a nice time to talk about policy issues and policy responses. So what I'd like to do is take the right-hand side of your systems mapping from Tuesday. When did we do that? Tuesday, Wednesday. Anyway, I'd like to take the right-hand side of that. I think it was Tuesday afternoon. And I'd like to look at some of the adaptation options that you've listed in there, and then start turning it around and talking about what would be some of the policy-related responses to that. So, so that would be my goal is on Friday, tomorrow afternoon, is to talk about, well, what do we do about subsistence agriculture? I mean, seriously, what can we do to make it more robust? What are some of the ways that, depending on whether you're talking about, I don't know, we can talk about, break it down to different types of production systems, et cetera. But I think that would be a useful use of our time tomorrow.
So, could you give the example of different kind of justice? Like the slides, I just not know.
Yeah. So, yeah, examples. Well, I think the examples here are so procedural justice is basically about people's ability to access the justice system or change policies and rules which affect them. So if you're a refugee and you're in another country, you have basically zero power over the rules and the regulations and the laws that affect you. Uh, in some cases, migrants eventually develop those capabilities to affect the legal system through political action and things like that in host countries, wherever they may be. But there's elements in which procedural justice affects many people, not just refugees, but also in the U.S., migrants are now being rounded up, herded, and brought into camps and basically sent home. And they have very little control over that policy landscape. Uh, the recognition, restorative justice is basically around trying to do reparations for losses and damages that occurred. So it's giving money and compensation. This is the basis for a lot of the lawsuits against the major oil companies, that some of which are taking place in the U.S. and other countries, where there's kind of saying, well, you knew all these years that fossil fuel consumption was going to create all these problems. You've profited handsomely now. Now it's time to restore to us some of the things that we've lost. In terms of climate and migration, climate visa programs would potentially recognize countries' emissions as they allocate visas to incoming migrants. That would be based on a restorative justice rationale. Finally, recognitional justice is basically just saying, look, it's like the Truth and Justice Commission in South Africa after apartheid. It's like, we acknowledge and we are basically saying that as a government we failed most of our population because we had an apartheid system that benefited only the whites. In the same way, there's just the recognition alone of ancestral sites or consideration of traditional people's knowledge systems like trust, reciprocity, responsibility. All those things can be important. Now there's hardly a meeting that takes place. I noticed at the beginning of our seminar, there was an acknowledgement that the ancestral lands of the people upon which this university has been built. We do the same thing in New York and in Columbia University. We say we recognize that this land was expropriated. I mean, it was just taken. Like, there's no way of whitewashing what happened. It was taken from the Lenape people, and we took it and we use it for other reasons. We're not going to be able to turn back the clock and give that land back in every case, but we can at least recognize that that was what happened. This same chapter I mentioned that we're doing has some great case studies in Honduras about some of the things that happen to women and girls, particularly when flooding occurs. And in West Africa, as fisheries have been declining and as the coast is eroding, what people are starting to think about and young people are considering when they consider the potential for migration. So I'll just leave this up in case you want to stay and read it. I think we have to have lunch. We're behind.
Sorry, Dr. Alex sir, for the insightful conversation or lecture on the climate migration theories, and also thank you for the participant for the engaging discussion. So now we invite all you in the Nehru Guest House for the lunch, and after lunch, please come again over here for the demonstration of the second tutorial. Thank you.
इधर फोकस करिए जब इधर आए ना. So a very good afternoon. I welcome you all this 4-day post lunch session. This is a lab and exercise. We had study one lab and one exercise, and I'm very happy that most of you did it very nicely. Although the exercise was very lengthy, and half of you did not had any exposure to software and the data and all, but still you did it. So we thought that exercise may take longer even today, but most of you have finished. So last late night we sat together and then we prepared another. In fact, we prepared these two exercises, but we thought maybe we'll finish only one exercise. So since we have done it, so I'm happy that we are going to do the second exercise. Otherwise, we could have engaged some other activities, some other lab work or tutorial. So I think that since last 4.5 days, uh, about four days, we are getting very good exposure of theoretical aspects of various dimension of climate change, displacement, vulnerability, and many more things. Right? Uh, I feel that apart from theory, you have to have a exposure and understanding of the practical aspect. So that once you become a policy maker or you're working in an organization, that adds to your department and for the benefit of the state or whatever you say. So in this study, we had a climate change vulnerability index we made. Now climate change vulnerability mapping we did it. Today what we are going to make is flood vulnerability assessment. So yesterday we use AHP and we are using another advanced method. This is a bit more complicated, more time consuming. But since we have only today time for the demonstration and lab, we make it in a very simple way so that you can do it. Right. So title exactly what we put it is flood vulnerability assessment using topo hydrological indices. Fuzzy analytical. It was yesterday it was AHP, now it is fuzzy. So we all know what is fuzzy. Entire universe is a fuzzy. Yeah? You say something, you understand something, I say something, I understand something, and I say what I'm saying, what I'm understanding is the best one. So it's all fuzziness, entire universe is fuzziness. But within a fuzziness, there is something which is real and concrete. So one need to agree on aspect which is close to the nature and which is good for the human and animal life, whatever you say. So the method what we are using the fuzzy AHP, and the first is this. There are three aspects. One is flood vulnerability, because floods what we are seeing today is again mainly attributed to climate change. Yesterday I showed you some slides on glaciers melt and on. The same is true for the entire world. So with that flood, climate change, what is happening? Flood is taking place across the world. Frequent flood. Flood is a natural phenomena, but it's a very frequent flood and devastating n number of people. And then the second issue is topo hydrological indices. Yesterday, what we took climatic indices. Those 6 indices we took mainly for temperature and precipitation. I showed yesterday the n number of indices you can choose as per your own need. But today, the different indices, that is topo hydrological indices, where the most of the indices are topographic, geographic, landform, right? Say slope, elevation, curvature, geomorphology, geology, and so and so. So these are the indices which plays an important role. There are two aspects. One is with the increasing temperature, snow and ice is melting, going to the river, flood is bound to happen, and then what is state of sphere on the surface of that. So therefore these are the topo hydrological indices. So let us go straight away to the steps, and I'm happy that yesterday you noted it down very nicely and understood the steps, and you did it. So these are the broad steps what we have. The first step, create flood conditioning factor as a raster layer. You must be knowing there are two layers, two broad layers. One is vector and second is raster. So vector layer is nothing but like a map. When you draw with a sketch, pen and pencil, that is a vector layer, which separate one entity with another entity. Whereas that is a discrete phenomenon. And raster layers are continuous phenomena, like satellite data. Each one cell has its unique value, right? If you have thousands and thousands of pixels, thousands and thousands, they have separate values. So it is a continuous feature. And we all know, I'll say a line or two on very childish thing, but which is very important. We know this line parser is what, this line parser is what, but computer do not know. Computer only knows 0 and 1, nothing else. So therefore, the lines and polygons what we have has to have converted into raster format. So therefore, what we have, conditioning factor as a raster layer, you need to create. How to create, from where the data source will come? I'll show you the data sources from where you can easily get it, free of cost, as I said did before. And then at the second step, reclassify these layers in ArcMap into 5 classes, 3 classes, 8 classes, normally odd classes, 5, 7, 9, 11, something like that. Now the question is when to create 7 class, when to create 3 class, right? I'm sorry. If the variation is more, if the variation in data is large and the extent and your study area is large, then you can go for more classes, 5, 7 or 9, 11. If the variation in data is less, then you can have lesser number. Ideally 5 classes is normally fair enough, right? Then after that, what you do is create a correlation matrix of flood conditioning factor obtaining weight through fuzzy HP. That is the most crucial and a typical step, right? Then at the fourth, apply a weight overlay in ArcMap. You apply a weight and you give weight, assign a weight in a way that has been given design and has been suggested by the expert committees, as we have studied also. And the last step, overlay the total then you get the flood vulnerability map, and then you need to relate what all is going to happen if you have certain number of population in a particular area, right? So now this is the most important slide. Our most important slide is that from where to get the base, the data source. So if you see this one, there are 4 broad categories of this factors, topohierarchical factors. One is rainfall, second is DEM, SRTM DEM, synthetic shuttle radar topographic mission, and third is satellite data Sentinel-2B, and fourth is geomorphology. When you use the rainfall, yesterday what we did, graded data, quarter degree, 1 degree data is also there, right? So it's up to you, what data, if you want a finer resolution data, you can go for quarter degree. If you need coarser resolution, 1 degree, right? Rainfall data from 1st January 1994 to 31st December 2022, from where we get IMD. You click on that and you get that, right? You can increase the time period, you can have a lesser time period, but no less than 35, 40 years or so. And the second, the data source, the topohydrological, the main base is SRTM DEM, which is a resolution of 30 meter by 30 meter. We know pixel is a square in shape. And what all we get? We get, using this DEM, we get slope, we get elevation, we get SPI, we get topographic wetness index, we get distance to river, we get drainage density, we get curvature, and we get convergence index. So you get 2, 4, 6, 8. This is 2014 data. Topography does not change much. It changed maybe in thousands of years. Slope change, yes, but not much. That again takes long period of time. These are natural phenomena. So this is 2014 data, and also because after 2014 SRTM data is not available. So we do not need. Even you see in earlier time what we used to have, topo sheet we used to have, and in topo sheet we have the contour in one, 20 meter, 40 meter or so, and we used it. And the topo sheet was surveyed way back in 1960s, 70s, Survey of India agency जो करती है. From where we get this SRTM data? We get it USGS, United States Geological Survey, Earth Explorer. And the simple, you must be having account. Those who do not have account, to them, you go and create an account. What you do, like a Google or Yahoo Mail. Create an account. You select the satellite. You select the sensor. You select the date and time, and then download. And each data, this data is a TIFF data, single band data. There are two broad categories of data. We all know. Just to tell a line for the because it's a mixed group. Not only geography and geology and civil engineering, but other students also, other participants. We have one is pan data, single band data, and multispectral. Say pan data is a single data, same as the DEM data is you do not need to recognize any object. By seeing the tone, you can see what is the elevation, what we did yesterday, right? We'll show you here. Then Sentinel-2B data is a 10 meter by 10 meter resolution, very good data, better than Astra data. With this data, what we get? Land use, land cover, and vegetation cover. These are two primary important layers we use to create even today. We have n number of other parameters and indicators. We get it from NDVI. Say for example, I showed you the day we studied in my lecture. We get vegetation density, leaf cover index, and so and so. But the base layer is a normalized differential vegetation index. We took for April 2024. The Copernicus, this is a website. You get the download data free of cost, not a single penny. It's a European Space Agency data. You get 2 data from here, 8 data from here, and 1 rainfall. And then by using geomorphology data at a scale of 1:50,000, at a regional level, at a basin level, the scale is fair enough. Otherwise, you can go for 2,50,000 or so. 2024, April, September. From where we got it? Bhukosh. It's a agency and organization by Geological Survey of India, GSIA. And then what you do? See this one. Since this is the main source of data for most of them, more than half of the data layers, indices, what we do is step and download them. This is a site, Earth Explorer. I've already showed you. Download DEM TIFF or .img. There are two formats which image processing software supports. Either TIFF or IMG, right? ADAS imaging support, IMG and TIFF both, and many other. You get DEM TIFF, the final output. Last column you see, output file. Then there is another data that is ALOS, pulsar data. It's a better data, 20.5 meter. So if you are doing a micro level, it is ideal to have data which has a better resolution, that is 20.5 meter. But it was most recent data. Earlier we did not have. We had only SRTM data 120 meter. Then we have a better data of 90 meter. Then further development in sensor technology, we had a 60 meter, and then the 30 meter. Till very recently, we used to have a 30 meter data, but we have a better data. It's up to you. So you do not ask me which data is better. It is up to you to choose and to decide. It is you, I not. Depending upon the accuracy, depending upon the size, and many more things, right? Both are same. In step 2, load the DEM data. In ArcMap, I'll show there. This is the steps. Then we go for customized accession check specialist. We have done this. I'll not spend much time on that. These are the steps I'll demonstrate. I do not want to go in this. I'll show on the system, on the software. That will make you better understand. Then this is a data set and raster layer creation. Some of it I've already talked about it to you. From where you get, say for example, when you talk about this one, satellite data, sentinel data, this is sentinel Copernicus, and these are data types. You have a data of 10 meter, 20 meter, 30 meter, right? And output you get as a composite picture, composite image. And then you have You add the data in the toolbar, and then there is a very simple formula to using this data, Sentinel-2 data, 10 meter or 20 meter, 30 meter. Again, this is a spatial resolution. We all know there are 4 types of resolution: spatial, radiometric, and temporal. And so spatial resolution, again, you want to have 20 meter or 10 meter. Again, depends on the nature of work. What you want to have. With that, you get the line to line cover. And for that, there are n number of line to line cover classification models. And the most commonly used is supervisor and unsupervised. So you go for supervised classification, recode it, and finalize it. In the first go, by using the Sentinel data, you get the line to line cover. And then by using that same multispectral data, 4-band data or 3-band data, you can go for creation of NDVI in image processing software, in RGI software. It's a very simple step. No, there are different band. We subtract band, infrared band with a red band, divide with infrared band with a plus red band, right? Then you go on this, say for example, what is that? Individual band stacked is done. There is another issue which is there in that, once you download any imagery, most of you must be knowing, but still I suppose half of you must not be knowing. When you go on a GLCF or USGS, you get the images band by band. Band 1, 2, 3, 4, 5, 6. And then you need to know which band makes a FCC or multispectral of that particular sensor. If you take Sentinel-2, it will have a different combination of bands. If you take Landsat 8 or Landsat 9, it will have a different set of band combination, right? So each band has to be downloaded TIFF one by one. Then in the software, the step process, we mosaic it, we layer stack it, so that you get the FCC. So this is what is written. I'll escape because of time. Then we calculate the NVI. This is a detail. Infrared minus band, red band upon infrared plus band. For Sentinel-2, it is band 8 and band 4. See here 5 and 4 here, but 8 and 4. Anyways, now then you calculate the NDWI, normalized differential water index. This is a formula. This is a band for which band? It's a very simple step. It will take you a couple of minutes. Then you drive the built-up index, many more things, right? Then I'll move on. This is from here the GIS work exercise starts. I'll show you in a minute. I have only a couple of slides, then I'll jump to the software straight away so that you can better understand. Yesterday I showed you add the data. You have added the data and this. Then you add the data of rainfall, elevation, the slope. These are the explanation of single line. You already know it. I do not want to read it. It's boring if you read a text, but sometimes you need to read it. And then curvature, that is influence of water, that is flow direction and concentration of water. Concave areas tend to collect more water and enhance the flooding. So you may be thinking why to need this data. So for that, it is a single line explaining the slope. Gentle slope favor the water accumulation. Where there is a steep slope, it will not accumulate water. Our objective is to model flooded areas, right? Then we have the drainage density, where we have the high drainage density. There are the chances of having more flood accumulation because in the river is already water, and then that will spill out. Then we have another layer, distance to river. The closer to the river, obviously, the better chances of being exposed to flood. Then we have the convergence index. Convergence index is a new layer, which most of you must not be knowing. This indicates where water accumulates. The place where water accumulates much. We all know, obviously, the flat area, in the flat area, the water will accumulate more. But if you move few meters from this place, even if you see with your naked eyes, that is a smooth, flat, but it is not flat. You drop of water, say half liter of water, and you see, even on this floor also, will start water flowing. So in that case, you need to know exactly where the water accumulates. For that, you need to have a convergence index, right? Then we have the NDVI, where we have dense vegetation. There is chances of less, flooding and all, because it promotes uh, uh, lesser flooding. Then stream power index, another important layer, which is erosive power of flowing water. Higher SPI values can indicate strong flow. Stream, this is stream power index. Erosive power, when the water flows, and if it flows at speed, if it's a volume, so it has a more chances of eroding something. So this is the a layer. Then we have the topographic wetness index. Higher the topographic wetness index, areas which will have a more likely chances of retaining water. Say for example, yesterday there was rain. The wet areas may retain water on the surface, but the dry areas, most of the water will be absorbed and will go down, and that may become the part of this groundwater. So therefore, this plays a negative role for them. Geomorphology geology is another very important issue that one need to terrains such as floodplain, valley, basin, inherited influence, accumulates of water and flow path. So geomorphology is also very important. Then a land use land cover. Say I was talking with one of the participant. If you go outside, we have the impervious surfaces. Highly pervious surfaces, you may not get much water logging. So that is another serious issue. Especially in the urban areas, not only urban areas, in the river valleys also, in the basin also. So these are the 12 layers we used. In fact, this is part of the work. This Intizar, who is sitting behind. So we took some of his, just to demonstrate you. This is the individual layer. I'll show you in a minute. This is a digital elevation model. This shows a height of 6534 meter and lowest is 287 meter. This is you see the shade, and you find where is this side we are closest to Himalaya, so therefore the height is more, right? So this is the layer what we have DEM, and this becomes a base layer for most of the spatial data layer, graphic layers. Now using DEM, we got the slope, right? And this is a slope which has a low slope. This slope in percent. We calculate slope in two ways. One is percent, another is degree. We all know. So what we have, you can see the color shade, and then this we get the slope, and then from slope we get the topographic wetness index. Then again we use, put it in a different color, use DEM. So DEM is the source for all these layers, and it takes hardly 2 minutes, a minute to create if you know the steps, right? So this is the topographic wetness. This is a water body. This is nothing to do with that. No, we need to look into this area. Then we have the convergence index. Again, we use the DEM. Then we have the curvature. Again, by using the DEM, we get the curvature map. Then we get the distance to the river. By using DEM, again, by using DEM, what we see, where are the rivers, where are the streams which is flowing, and it gives you an idea where all this, these are the rivers, that is the distance to river in a particular river basin again. And river basin flows where? In the low elevated area, and obviously water keeps going and then keep on flowing with the. So this is a distance to river map. Then we have a land use map data from Sentinel-2. You see, these are the different land use classes: water bodies, sparse vegetation, dense forest, built up and barren. Now, I always say to all students that you need to follow a particular classification scheme, a standard classification scheme. And the standard classification, when you talk about, so we have the NRC standard classification scheme they have given, like we have the Bureau of Indian Standard, We have the WHO standard, we have the other agency standard. Same is true with the land use classification. You cannot go as per your own wishes. There is another international standard, that is WGS, USGS standard. Then other scholars have made it different classification scheme, which is acceptable to the larger researchers. Land use map ban gaya hamara aapka, then you go for NDVI. Lower the values, lower the vegetation, higher the values, higher the vegetation. It varies between plus minus 1. Right? Then we have the stream power index, right? Again we use the DEM. Then we have the geomorphology map that we got it from Bhukosh Bhuvan. So from there, earlier what we used to do when we were doing research long back, so we need to depend on the topo sheets or geology maps. And from there we trace on a butter paper and we use it. Now you do not need to do that. And creation of data takes 90% of time. In fact, 95% of time, in some cases 98% of time. When you have created your data layers, be it a 10, 20, 40, whatever, the modeling, if you know you are expert enough in GIS remote sensing, modeling takes 10% or 5% of time. Right. So therefore, what the Westward do that? We have the very large labor force. They ask to create a data layer, unless they do that. दिमाग वाला काम वो करते हैं और लेबरगिरी हम करते हैं, एशिया के लोग, है ना? आपने देखा जो हम देख रहे हैं आज, वी ड्राइव इन द कैब, तो कैब में ड्राइव करते सारा डेटा एक एक उसको उन्होंने आपसे बनवाया, बनवाने के बाद में, राइट? सो एनीवेज, सो व्हाट वी हैव, ये जियोमॉर्फोलॉजी मैप अब बना बनाया मिल जाता है, आपको कुछ नहीं करना है, रेडीमेड गेट डेटा यू गेट इट. And these are the geomorphology class: active floodplain, active quarry, dam and reservoir, and many more: river, piedmont slope, road cutting, and young alluvial plains and so and so. Right? इसमें हमें अपना दिमाग नहीं लगाना है. Software will take its own course. कि इसका क्या रोल है फ्लड में, इस जियोमॉर्फोलॉजी, इफ इट इज दिस क्लास इन अ पर्टिकुलर एरिया, इसका क्या रोल है, या क्या रोल होगा. द एक्सपर्ट पीपल हैव डन इट एंड वी नीड टू गेट द आउटपुट by creating data layer. Now, from here what we do is, we navigate, we do that, reclassify, we classify into 5 classes, because again we need to put on a certain uniform classification scheme. So as I said, कि 4 class बनाना, 5 बनाना है, 3 बनाना है, 7 बनाना, so we make 5 classes. Now this, for this study area, it was suitable to have 5 classes. So what we do is, we go to special analysis tool, reclassify, then we go and take this elevations here, TIFF, the data what we have done. So this is a TIFF elevation data that is displayed here. We take the value, reclassify class, and then we go for 5 classes. And then we give the output what we did yesterday, and we'll do it today also. So what we have, repeat the same process. Once you've created data, take one data every time and declassify into 5 classes, and then it will be a separate layer. So your original data will be remain as it is. वो कुछ चेंज नहीं होगा, है ना? सैटेलाइट डेटा से आपने कोई चीज़ निकाला, SRTM से कोई चीज़ निकाला, वो that will again it will be same as it is. किसी को दे दो, 10 साल बाद भी यूज करो, doesn't matter. So this is what I have written here. Repeat the process for all 12 conditioning parameters. In your case, you may take 6, 8, 20, 25, whatever, right? So you have to do this, and we'll move in a lab. और आप सबको करना पड़ेगा, है ना? पहले का लेयर हमने बना रखा है, because we do not have much time कि हम आपको कहें कि साहब लैंड यूज बना दो, NDVI निकाल दो, तो लैंड यूज NDVI बनाने में 2 घंटा लग जाएगा, और बाकी 12 लेयर बनाने के लिए एक वर्कशॉप और करनी पड़ेगी, 5 दिन का और. But we have, my scholars have worked very hard. All of them are sitting, they are participants also. So in that way, I'm saying that at least you get to know. Once you learn here, you will provide all manual, data is freely available. If you put it in front of you, the copies and steps, you can explore and you can do much better. And that is one of the most important objective. Climate change vulnerability, flood की बात करो, desertification की बात करो, वो भी एक है. We did one work on Latur, तो वो भी that was published. And if you do this good study and modeling and analysis, you can go for good publications also. Right? Now, so what it gives you, these are reclassified layer. What I said here ना, कि ये एलिवेशन हो गया रिक्लासिफाई को, जो ये दिस इज ओरिजिनल, जो यहाँ पे रिक्लासिफाई करके बाद आएगा जो डेटा, दैट इज डेटा इज हियर. सी, सो एलिवेशन, क्या कहते हैं, कन्वर्जेंस इंडेक्स, डिस्टेंस टू रिवर, कर्वेचर, डेंसिटी, ये सारे नीचे और छिपे हुए हैं. सो रिक्लासिफाइड लेयर, जस्ट आई एम शोइंग यू वन. और जितनी बार करोगे, एक चीज और चाइल्डिश में बताऊं, जितनी बार करोगे उतनी बार ये कलर बदलता जाएगा. आप कलर कॉन्शियस हो तो आप इसको कलर बदल दो जो आपका अच्छा लगे. ये n नंबर ऑफ ड्रॉप डाउन में है ना. बट आई सजेस्ट दैट यू नीड टू फॉलो द साइंटिफिक प्रिंसिपल ऑफ यूजिंग एनी कलर कोड्स, कार्डोग्राफिक प्रिंसिपल्स. उसके पीछे कुछ साइंस है ना. अपने कपड़े तो अपने हिसाब से खरीद लो, है ना, लेकिन आप जो है इसको फॉलो करो. दैट इज माई हम्बल एडवाइस. आप करो ना करो अलग बात है. देन स्टेप 3, अब ये थोड़ा सा मुश्किल एस्पेक्ट है. इसमें हम नहीं टाइम स्पेंड करेंगे और आपको भी नहीं कहेंगे इसमें टाइम स्पेंड करो. इसमें क्या करना है, बाय यूजिंग फजी, स्टेप 1, वेट, वी कैलकुलेट वेट ऑफ ईच पैरामीटर, कि कौन सा पैरामीटर कौन कितना भारी है. नेता होते हैं ना, बहुत भारी नेता होते हैं, बहुत बड़े होते हैं, जो कह देंगे पार्टी के लोग मानेंगे. तो ये जो आपके 12 लेयर हैं, तो 12 लेयर इज वन, ईच लेयर हैज सोन रोल. अब वो सभी इंपॉर्टेंट है, लेकिन कौन कितना इंपॉर्टेंट है वो हम बताएंगे या जो एक्सपर्ट बताएं. बट दिस इज हियर द फजीनेस कम्स इनटू पिक्चर, कि आप वो जो अलग अलग आप रीड द लिटरेचर, पेपर पढ़ो, और रिसर्च करने के लिए ये कहा जाता है कि रीड मोर एंड मोर रिसर्च पेपर्स, सो दैट यू गेट ब्रॉडर अंडरस्टैंडिंग कि क्या चीजें हैं, किसने क्या किया, एंड हम इसमें क्या और नया करें, कुछ अच्छा करें, सो दैट यू गेट द बेटर रिजल्ट. व्हेन यू सेंड अ पेपर, तो वो ये कहता है कि आप कितना भी अच्छा करके भेजो, तो रिव्यूअर सेज कि वेयर इज अ नॉवेल्टी, व्हाट इज न्यू, देयर इज नथिंग न्यू टू इट. लेकिन हमारे लिए तो बहुत अच्छा नया दिखता है. वो क्यों दिखता है? दिस इज माई फॉल्ट, दिस इज नॉट हिज फॉल्ट. हमने इतने पेपर नहीं पढ़े, उसने पढ़ रखा है, तो हम तो कहते हैं इसमें ये नया है, बट आई डू नॉट नो, इसलिए आप लेस रेड. So therefore, reading literature is most important, right? तो ये आप weight assign करते हैं, based on the expert judgment, right? तो इसमें अब ये देखो, एक तो ये मैं कह रहा था, this is individual layer का रोल. अब उस लेयर में से for example if I made 5 classes, अब उस 5 classes में कौन ज्यादा इंपॉर्टेंट रोल प्ले कर रहा है, इंपॉर्टेंट नेगेटिव रोल प्ले करता है वो फ्लड, ठीक है ना. तो उसको भी हमें देखना पड़ेगा. तो वन इज इंडिविजुअल लेयर एंड अनदर इज विद इन ईच लेयर द जो क्लासेस है वो क्या रोल प्ले करेंगे. से वेजिटेशन एनडीवीआई की बात करें, एनडीवीआई वैल्यू से 0.2 to 0.7, उसमें 5 क्लास कर दिया, तो 0.2 to 3 वाला ज्यादा प्ले करेगा नेगेटिव रोल और या 0.7 वाला. सो नो, तो दैट इज व्हाट हम वेजिटेशन को बहुत अच्छे से समझ पाए. जियोमॉर्फोलॉजी को हमें नहीं पता ठीक से, कर्वेचर को नहीं पता हमें ठीक से, बट दे नो, एंड देन अकॉर्डिंगली एज पर देयर, उनके लिटरेचर पढ़ने के बाद देन वी असाइन अ वेट. नाउ फजी इन AHP, the comparison matrix is constructed using expert judgment, what I was saying, to evaluate the relative importance of each pair of criteria using fuzzy numbers, typically triangular fuzzy number, TFN, right? ये करते हैं. then what we have, expert compare each pairs of factors, कि रेनफॉल का स्लोप से क्या रिलेशन होगा, स्लोप का वेजिटेशन से क्या रिलेशन होगा, स्लोप से जियोमॉर्फोलॉजी क्या रिलेशन होगा, 1 to 1 and 1 to many. तो ये बहुत मुश्किल काम है, बट दिस स्ट्रॉन्ग पावरफुल सॉफ्टवेयर एंड कंप्यूटर has made it possible. You do it in say few minutes, right? So which one is equally important? इसमें 3 चीजें आती हैं, equally important, moderately or more important, or extremely or more important, which are then translated into corresponding triangular fuzzy नंबर, फिर ये आता है एक मैट्रिक्स बन के आता है, क्रिएशन ऑफ पेयर वाइज कंपैरिजन मैट्रिक्स। आपने देखा हो स्टैटिस्टिक में, से फॉर एग्जाम्पल स्लोप, स्लोप को स्लोप से लोगे तो इक्वली इंपॉर्टेंट है ना, है ना। आपके रिश्तेदार हैं तो वो भी बड़े अच्छे होंगे, हम भी बहुत अच्छे होंगे, है ना। वो करोड़पति हैं तो हम भी करोड़पति होंगे, है ना। तो इट हैज अ 1 to 1। लेकिन दूसरे से उसका इंपॉर्टेंस कम होगा। तो उसमें 3 चीज आती है, लोअर, मिडिल एंड अपर, लोअर बाउंड, मिडिल बाउंड एंड अपर बाउंड। सो मैं इसमें बहुत नहीं जाऊंगा बिकॉज बहुत स्ट्रॉन्ग स्टैटिस्टिक्स है, मेनी ऑफ थिंग्स आई डू नॉट नो ऑल्सो, बट आई नो हाउ टू डू इट, माई स्टूडेंट नो हाउ टू डू इट। तो उतना ही बताऊंगे जितना आप, चूंकि बहुत सारे लोग नए हो। सो व्हाट वी गेट अ EHP एंड फजी EHP कंपैरिजन। जो हमने कल किया था वही है EHP। एक हर उसको लेयर को आपने उसका वेट दिया, दैट इज कॉल्ड सैटी स्केल, आपने पढ़ा होगा मैथमेटिक्स में, स्टडीज में। इसको 1 दिया, इसको 3 दिया, 1 जब देंगे इक्वली इंपॉर्टेंट, बराबर का है, 3 है मॉडरेटली इंपॉर्टेंट, 5 इज स्ट्रॉन्ग इंपॉर्टेंट, 7 देंगे वेरी स्ट्रॉन्ग इंपॉर्टेंस, 9 इज एक्सट्रीमली इंपॉर्टेंट। We cannot give 10 because there is nothing perfect in nature सिवाय भगवान अल्लाह, है ना। हम कितनी भी अच्छी मॉडलिंग कर लें तो we get the accuracy of 9.9999 चलते चले जाओ, हजारों डेसिमल, तब भी नहीं अचीव कर सकते, बिकॉज इट्स यूनिवर्सली प्रूवन कि नेचर में कोई चीज़ परफेक्ट नहीं है सिवाय अल्लाह ने जो बना दिया। जिस हिसाब से सूरज की रोशनी आएगी, जिस हिसाब से जो चीज़ें हैं, हम आप कितना भी कर लें, बट वी कैन नॉट 100% एनीवेज, वी ट्राई टू रीच मैक्सिमम परफेक्शन। तो ये हमारा और रेसिप्रोकल है कि कुछ उसके उल्टा, मतलब यू डिवाइड वन विद अनदर एंड देन सी व्हाट इज, देन फजी EHP में क्या होगा, 1 1 1 2 3 1 4 5 6 and 8 9 1, and then reciprocal 1 upon another layer, then, and this is lower bound, middle bound and upper bound, right? Then we create a pairwise comparison matrix, right? जैसे हमने कहा 1 1 इसके पहले भी आया था, if we divide it by 3 it will come, 1 को 3 से डिवाइड करेंगे तो 0.33 आएगा, right? 2 से करेंगे तो 5 आएगा, और आपको 4 से करेंगे, 5 से करेंगे 2 आएगा, और 4 से करेंगे 0.25। we get this is done in the उसमें, और this is what we have in the next step. We create a pairwise comparison of matrix, and then in the next step we normalize the pairwise comparison of matrix, say C4 divided by C$16। this could be, यहाँ पे दिख नहीं रहा है, एक रो होगा एक कॉलम होगा, and once we click it you get certain value, so that value get translated here, right? For each parameter, for elevation, for slope, lower, middle, upper, for drainage density and so, right? Then we, in the step 4, for each criterion, each row calculate the geometric mean for normalization of lower, middle, upper, because normalization of data is the most important. ऐसा नहीं कि आप डेटा कुछ भी ले लो और उसको फिर आप करते चले जाओ, we need to normalize. I give one example, very simple, छोटा सा example दें कि data of say 100 rows, 100 columns, उसमें कुछ values हैं, चाहे एज का हो या सेक्स का हो या कोई डिजीज हो, इनकम हो, देयर आर सम एक्सट्रीम वैल्यूज, होता है नहीं, एंड एक्सट्रीम वैल्यूज गेट डिस्टर्ब द इंटायर रिजल्ट। सो वन नीड टू सी, एंड व्हाट वी डू इन अ सिंपल वे, वी ओमिट एक्सट्रीम वैल्यूज। एक्सट्रीम कुड बी इन अ लोअर बाउंड एंड एक्सट्रीम कुड बी अन अपर बाउंड। एक वैल्यू है से फॉर एग्जांपल 98, अब बाकी सारे वैल्यू हैं कितने पे, 20, 10 या 30, वो सारा पिक्चर खराब कर देगा, और बाकी सारे ऊपर है और कुछ नीचे है। तो व्हाट वी डू इज वेरी सिंपल, एक्सेल में भी करते हैं अदरवाइज, कि वी नॉर्मलाइज इट, और नॉर्मलाइजेशन से और भी बहुत सारे तरीके हैं, दिस इज नॉट जस्ट वन, दिस इज वन आई एम गिविंग द एग्जांपल। ये ज़्यादा करते हैं, आई escape most of the statistics because we take the sum of all geometric mean, then we take reciprocal of total geometric mean 1 by 1, and then we take the average of reciprocal in increasing order. Then we go for multiply each geometric mean to reciprocal. We get this step 8. Then we get defuzzification of the average values of lower bound, middle bound, and upper bound. We get this value. Make sure that sum of weight should be 1, otherwise we have to normalize this again. जितने होंगे सबका normalize करने के बाद obviously total should be, if we talking about something 100% होना चाहिए, कुछ values है, कुछ figure है, तो उसको 100 से ज़्यादा ना हो, 100 से कम ना हो. So I come on this the last part. What we have, multiply this weight by 100, because in our map it makes compatible, and then it has to be obviously 100% weight. Outcome, the resulting multiply normalized weight represent the relative importance of the each criterion, and that we use for the modeling of the different area. Now, so what we have done, you see this one, उसमें आप नहीं जाइएगा, उसको समझने के लिए you need time, कई दिन चाहिए, तो उसमें मत जाइएगा. I think we'll provide the Excel in the lab, और उसमें बहुत ज़्यादा मत जाइएगा, नहीं तो फिर उसी में टाइम निकल जाएगा. बट कुछ समझ लीजिएगा ब्रॉडर, है ना. कुछ हम लोग रहेंगे सब लैब में, जैसे कल सब हमारे मतलब टीम के लोग थे और स्कॉलर्स भी थे, हम सब लोग पीछे आपको जहाँ जिसको दुश्वारी थी बताते थे. तो इसमें अगर जो आप सोचे कि इसको समझ के आगे चले तभी होगा, तो फिर कुछ नहीं कर पाएंगे. इसको बाद में समझिएगा, है ना, तो ज़्यादा अच्छा रहेगा. देन व्हाट वी डू इज we go for reclassifying, and this is what we have: relative weight 1, 2, 3, 4, 5, right? And what we do is we go in this spatial analysis overlay and then weighted overlay. So what we did yesterday, we did fuzzy membership in the last exercise, and then we did fuzzy overlay. It was simple overlay, and this gives a result good, but this fuzzy HP gives better result. That is better, modeling. And above that, you want to have a better, analysis, better modeling. Then you go for machine learning and all. Then deep learning, AI का सब part है. Artificial intelligence में चले जाओ. Explainable AI में चले जाओ. That explains further कि what all the parameters, how they contribute, why that is not contributing. वो बहुत सारी चीजें, अब ऐसी टेक्निक, ऐसी चीजें आ गई तो wonderful. Anyways, तो इसमें हम जाते हैं, वेटर ओवरले जाते हैं, करते हैं, एंड देन सी हियर, यहाँ पे जो सम इन्फ्लुएंस 100 आना चाहिए, राइट. यहाँ पे 100 आना चाहिए जो हम कह रहे थे एवरेज आने का, राइट. एंड देन वी गेट द आउटपुट हियर, वी गेट द आउटपुट, एंड देन दिस इज अ क्लास वेट स्कीम फॉर दिस. व्हाट वी हैव हियर, व्हाट वी हैव, द टोपोग्राफिक weight percent is 10, slope has 12, density is 13. So if you analyze this column, what do you find? You find that the most important, criterion is drainage density, followed by slope. Slope होगा तो पानी निकल जाएगा, आपको कोई impact नहीं कर रहा. Then we have the land use, and followed by main. Now, say for example, if we then this is one for each layer. अगर 20 लेयर है, 25 लेयर है, 50 लेयर, तो सबका ऐसे निकलेगा, सबका ऐसे निकलेगा. रिलेटिव वेट ऑफ ईच पैरामीटर, कौन कितना इंपॉर्टेंट है. किसी फंक्शन में बहुत बड़ा आदमी होता है तो बहुत ऊपर बैठाया जाता है, बहुत अच्छे कुर्सी पर बैठाया जाता है, उसका हायरार्की होती है ना. तो उसी तरह से ये भी है, सब मिलके एक साथ काम करते हैं. व्हाट वी हैव, बट विद इन दैट, अब इसमें जो है क्लास 1 होगा तो इसको 1 ही साइन करेंगे, यहाँ 2 करेंगे, यहाँ 2 करेंगे, 4 करेंगे, उसको 5 करेंगे. ये जो मैट्रिक्स देख रहे थे उससे सारा निकल के आता है, राइट. नाउ व्हाट वी गेट द आउटपुट, वी गेट द आउटपुट व्हाट वी डिड यस्टरडे, ओवरले किया, फजी ओवरले किया जो पहले देखा था, एंड यू गेट दिस. एंड दिस इज द फ्लड ससेसिबिलिटी मैप, कि कहाँ ससेसिबिलिटी फ्लड की ज्यादा है या कहाँ कम है. नाउ सी दिस वन, जहां रेड पैचेस जो भी देख रहे हैं आप, वहां पे हाईएस्ट ससेसिबिलिटी होगी. एंड दिस इज द वेट लेयर, you get that output. And in the last, द सेंसस मैप लिया आपने, डेटा लिया वहां से, पॉपुलेशन डेटा लिया जो आपने कल किया था, सेम वीडियो वी अप्लाई ओवरले. कल हमने देखा था क्लाइमेट से कितने लोग इंपैक्ट हो रहे हैं. नाउ व्हाट वी सी टुडे इन दिस एक्सरसाइज, दिस इज अगेन वेरी इंपॉर्टेंट, एक्सट्रीमली इंपॉर्टेंट, कि कितने लोग इंपैक्ट हो. पॉपुलेशन तो वही रहेगा, बट इफ यू टेक 2024 डेटा, 21 डेटा, तो फिर उसमें सीनरियो बदल जाएगा. हो सकता है बहुत सारे लोग माइग्रेट हो गए होंगे. व्हाट एलेक्स वाज सेइंग, क्लाइमेट इंड्यूस माइग्रेशन, यहाँ से माइग्रेट हो गए चले गए. अच्छा, हिंदुस्तान में क्लाइमेट इंड्यूस माइग्रेशन कम है हमारा, है ना, बट पीपल आर वेरी सेंसिटिव इन द रेस्ट पार्ट ऑफ द वर्ल्ड. हमारे यहाँ वी आर ओनली सेंसिटिव टू मनी. लक्ष्मी जी, जहां पैसा ज्यादा मिले वहीं चल दो, भले ही हमारी जिंदगी 10 साल बाद खत्म हो जाए, ऊपर ना करें, बट पीपल, दैट इज, यू नो, डिपेंड्स, that depends on individual, but we should be very sensitive to the nature, कि नेचर को हम प्रोटेक्ट करें, क्लाइमेट को प्रोटेक्ट करें. जो हमने कल दिखाया था आपको कि व्हाट वी हैव शोन कि इंडियाज पर्सपेक्टिव, इंडिया लॉट ऑफ मनी, $1 billion इज बीइंग स्पेंड, ताकि हमारी जनता ठीक रहे, स्वच्छ रहे, सही से रहे. सो दिस इज हाउ वी डू इट. सो यू कैन हैव पॉपुलेशन या कोई और चीज को देखो, यू कैन ओवरले, एंड देन दैट एंड्स हियर. नाउ दिस, in terms of presentation and writing part, I'll come to the software and then I'll demonstrate some of the layer, because if I keep demonstrating all the layer, we'll finish time here only. I feel that we should have a, you know, much time for hands-on practice, and yesterday I'm very happy that you did it till 6:30 and 7. Lab is open, you know, जब तक आप कहोगे लैब खुला रहेगा 7 बजे, 8 बजे, 9 बजे रात तक. If you finish it early, you can leave early. So we'll see here. We'll come to the software now. I'm sure कि बहुत सारे लोगों को आप सॉफ्टवेयर आ गया होगा और जो अपने बहुत सारे लोगों के पास है भी. What is the folder, इंतजार? Where is the folder? This is one. हमें एक बार बता दो फिर हम. सी में जाओ पहले, दिस भी सी. अच्छा ठीक है, बस राइट, ओके. Those who are in the back side may move forward, because the size is very small. File name is small and the steps in the software is also small. So I request please move on so that you can have better. If you are fine sitting backside, you can read it fine. Okay, this is a data, dem data. This is a dem data. This is one scene, right? This is one scene. But my basin is something like zigzag. So I need to clip, right? जैसे हमने कल किया था वैसे इसको क्लिप कर सकते हैं. This is dem data. What we have, the high 1096 and this is lowest is 184, right? Dem data. अब इसको हम हटा देते हैं and then we go to, just to show you, जब डाउनलोड करोगे सिंगल फाइल होगी और it will look like this. And wherever you click here, आप देखो जो कैसे मैं पहले भी बताया था, if you take this icon I और आप यहाँ क्लिक करोगे तो what it shows, pixel value 730. That is elevation in meter, right? And if you click here on a darker pixel, this is 225. Value will be same, but if you invert करोगे तो ये brighter वाला dark हो जाएगा, dark वाला, but value will be same, but only weaving, weaving will be change. उसको समझना देखना ही बदलेगा, बाकी सारी चीजें वैल्यू नहीं चेंज होगी. Now let us go quickly. I remove this. I've showed this. Then sentinel data. कौन सा है अंदर इसके है क्या कहाँ पीछे जाओ आइए वाला है so you have not made FCC okay तो छोड़ो फिर कोई फायदा नहीं इसको दिखाने में we go straight away he is not make no the composite so anyways we take the dem data जो dem data क्रॉप किया था वो किसमें है dem data इसमें बेसिन वाला देखो एक ये में करा था एक जगह डाला एक में पंच फोल्डर इसको बना के उसमें डाल एक फोल्डर दिखा बस बस ये चीज that's fine okay fine this is what I asked this is the base layer 12 layers what we have so what we have is here this is the elevation this is elevation we have clipped it to the basin extent then we have डेम पूरा नहीं जैसे स्लोप निकालने के लिए कहाँ डेम इसमें चलो so say for example this is a नहीं this is elevation है डेम वाला कहाँ है अच्छा चलो ये इसी को डेम नाम दिया ना फाइन See this is the dam Beas basin right इसके पहले जो दिखाया था हमने आपको वो दिखाया था then to create slope and aspect curvature everything what you need to do is you go to spatial analysis then go to surface right मैं वापस दिखाता हूँ एक बार go to ArcGIS tool इस तिजोरी में जाइए और तिजोरी में जाने के बाद फिर go to spatial analysis tool then go to स्पेशल एनालिसिस और इसमें स्पेशल स्टैटिस्टिकल भी है बहुत सारी चीज़ें ट्रैकिंग एनालिसिस है आप इफ आर वर्किंग ऑन ट्रांसपोर्ट इश्यूज ट्रांसपोर्ट प्लानिंग और सारी इसमें सो वी गो टू स्पेशल एनालिसिस टूल देन वी गो टू सरफेस वी वांट टू डू द सरफेस एनालिसिस व्हिच कवर्स स्लोप एलिवेशन कर्वेचर एंड ऑल सो देन वी गो टू स्लोप एंड आई टोल्ड यू वेयर यू सी द हैमर वो ऑपरेटिंग लेयर है डबल क्लिक यहाँ पे करना पड़ेगा you take the input layer this is a dem TIFF right then you give the output I made a test file so that I can delete it should mix with the other files हमने इस पे कहा slope 2.tiff do not forget to put the TIFF then this is all no change then say okay so model is running you see below blue color see this one we have not applied this operating layer mask and all otherwise and it has no value in fact it will give the some random values but it's not true value यहाँ पे क्लिक करेंगे तो इसका भी देखो 0 दिखा रहा है even if it gives a value तो इस तरीके से what we have got the slope then we get we can get what all we have curvature aspect we do not need here aspect is not that important that may be important for some other establishment and all curvature we need it curvature में हम जाते हैं and then curvature में हम ब्यास रिवर पे गए but वहाँ से भी जा सकते थे हम what we do then we give the aspect here sorry curvature dot TIFF right and nothing else I need to go to environment to mask and all I leave it because you already know it to save time ताकि हम क्विकली जा पाए लैब में. You have already understood this step. I hope it should come. It comes. Something went wrong. क्यों भाई? Something went wrong. We may do it again. कहाँ गया? Bias rem. We're already here. We go curvature. If the file, we take the slope. Curvature 2, let's say put it 2. It comes. Right? So same way what we have done, इसको हम हटा देते, मास्क कर देते, तो ये बेसिन का आउटर लेयर है, बाहर वाली चीजें नहीं आती. राइट? इस तरीके से हमें सारी चीजें बना लेनी है. Basically you will get it in a lab. ये सारे लेयर you can make your own, right? Then after that let me go to other layers. These are layers. Say land use map. This is land use map. What I've showed you. You'll use this. You're not going to make it. Then the other layer what we have is NDVI. This is the vegetation, layer. Then we have geomorphology map. We get it from that ready-made map. For NDVI, for the slope, curvature, you have to create by using the DEM. Then what we have is distance to river, right? The same map I've showed you in my presentation. After doing this, once you do it, I do not want to do all. I do not want to show it. You do it yourself in a lab. ये सब करने के बाद फिर रेनफॉल का है, वेटनेस इंडेक्स का है, सारे हैं. Then you go for reclassifying, right? We go to same spatial analysis tool. From ArcGIS toolbox, go to spatial analysis tool, and then go to reclassify, right? Then I'll remove these layers because there's no need to put all. I just put it to show you. Then go to reclassify, right? And reclassify, maybe I open it. ये इसमें सारे वो लेयर है ना, इसको ऐड कर ही लेते हैं. What you need. Okay, fine. That will be good if you add the layers what you have created, right? So that it will be easier for density. Then we have elevation. Then we have geomorphology. A land use class. And AVI. Then we have the slope. Rainfall. Okay. Now you go to, have you noted it down? Reclass, then you go to to reclass, choose one layer one by one. Say I take topographic witness index, right? It will value, choose a value, and then you see, you say there are n number of classes here. You say classify, right? And then when you go to classify, go and check, select here 5 classes, right? Take this 5 class, and how it can be classified? There are different ways of classifying. If I want to make 5 groups of all participants, 6 or 7 participants, हम एज के हिसाब से कर सकते हैं, नंबर के हिसाब से, रीजन के हिसाब से. व्हाट ही डिड अलग यहाँ पे स्टैटिस्टिकली व्हाट वी हैव manually we can do it. Equal interval can be done, defined interval, quantile, natural break, and many more. We use normally natural break, right? natural break हम लेते हैं. Standard deviation भी है. If you take standard deviation तो ये कहेगा कि how much is standard deviation, half, 1/3, 1/4, right? ये सारी चीजें हैं. So anyways, I do not want to spend much time. Equal interval, eh? Well, this is what we did. No, sorry, natural break, right? 5 classes. 5 classes, okay? I say okay, and then I need to give a new file, new name. What is this? TWI. TWI. Underscore reclass. .if, yes. Right? ये ले लिया, then say okay. Just 5 class ये आ गया. The same thing you have to do one by one. Sorry. Reclassify. हम यहाँ से चले जाते हैं जियो प्रोसेसिंग से, एंड देन रिजल्ट्स. यहाँ से जल्दी हो जाएगा मेरे ख्याल में. कहाँ आ गया? What is that? Current. This is reclassify. Right? I select the layer. SPI, TWI हो गया, ठीक है? SPI. And do not forget to give underscore and then reclass. Sorry. SPI, right? Value हो गया, and then classify. We go 5 classes as we did before. What happened? कुछ गलत select हो गया, ठीक है ना? What? I'll go for that. अभी हमने क्लास दिया है. Then हम देंगे ये SPI underscore reclass .if. ठीक है साहब, कुछ छूट तो नहीं रहा? Please remind me if I make any mistake. ये SPI भी 5 क्लास में बन गए. Then we go next one. Input raster, rainfall, classify, 5 classes. This is a rainfall, rain, reclass .if, right? ठीक है साहब, Everything is okay? There's rainfall. Slope. Sorry. Rain. Just slow. Sorry. Slope. 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 Yes. Right. Then next, land use. LULC. Geomorphology. है क्या है? रिक्लास है, पहले किया था शायद. Let us do it again. पता नहीं क्या है. I don't know. है क्या? हाँ वही. We do it. No issue. We do it. Yes, we change it. Right. Geomorphology. Right. Reclass 2. Elevation. This is elevation, na? Elevation. Density then. I make it DD, drainage density, short name. The second last layer, distance to river.